What's going on, everybody? Welcome back to another video. Today, we are going to be learning pandas in under 3 hours. So in this lesson, we're going to cover a ton of things, as well as some projects at the very end. You're going to learn how you can read data into pandas and actually store it in a data frame. We'll be filtering, querying, grouping, and a ton of other things just on that data. And then we'll be diving into data visualization, data cleaning, exploratory data analysis, and a ton more. So without further ado, let's jump on my screen and get started. So the first thing that we need to do is import our pandas library. So we're going to say import, and we're going to say pandas. Now this will import the pandas library, but it's pretty commonplace to give it an alias. And as a standard when using pandas, people will say as PD. So this is just a quick alias that you can use. That's what I always use, and I've always used it because that's how I learned it. And I want to teach it to you the right way. So that's how we're going to do it in this video. So let's hit Shift Enter. Now that that is imported, we can start reading in our files. Now, right down here, I'm going to open up my File Explorer, and we have several different types of files in here. We have CSV files, text files, JSON files, and an Excel worksheet, which is a little bit different than a CSV. So we're going to import all of those. I'm going to show you how to import it, as well as some of the different things that you need to be aware of when you're importing. So we're going to import some of those different file types, and I'll show you how to do that within pandas. So the first thing that we need to say is PD dot, and let's read it in a CSV because that's a pretty common one. We'll say read underscore CSV. And this is literally all you have to write in order to call that in. Now, it's not going to call it in as a string like it would in one of our previous videos if you're just using the regular operating system of Python. When you're using pandas, it calls it in as a data frame, and I'll talk about some of the nuances of that. So let's go down to our File Explorer. We have this countries of the world CSV. You just need to click on it and right click and copy as path. And that's literally going to copy that file path for us. So you don't have to type it out manually. You can if you'd like. And we're just going to paste it in between these parentheses. Now, if we run it right now, it will not work. I'll do that for you. It's saying we have this Unicode error. Basically what's happening is it's reading in these backslashes and this colon and all those backslashes in there and this period at the end. What we need to do is read this in as a raw text. So we're just going to say R, and now it's going to read this as a literal string or a literal value and not as, with all these backslashes, which does make a big difference. When we run this, it's going to populate our very first data frame. So let's go ahead and run it. And now we have this CSV in here with our country and our region. Now, if we go and pull up this file, and let's do that really quickly, let's bring up this countries of the world. It automatically populated those headers for us in the data frame, but we don't have any column for those 0, 1, 2, 3. So if we go back, as you can see right here, there's this index, and that's really important in a data frame. It's really what makes a data frame, and we use index a lot in pandas. We're able to filter on the index, search on the index, and a lot of other things, which I'll show you in future videos. But this is basically how you read in a file. Now, if we go right up here in between these parentheses and we hit Shift Tab, this is going to come up for us. Let's hit this plus button. And what this is these are all of the arguments or all the things that we can specify when we're reading in a file. And there are a lot of different options. So let's go ahead and take a look really quickly. Really quickly, I wanted to give a huge shout out to the sponsor of this entire Pandas series, and that is Udemy. Udemy has some of the best courses at the best prices, and it is no exception when it comes to Pandas courses. If you want to master Pandas, this is the course that I would recommend. It's going to teach you just about everything you need to know about Pandas. So huge shout out to Udemy for sponsoring this Pandas series, and let's get back to the video. The first thing is obviously the file path. We can specify a separator, which there is no default. So when we're pulling in the CSV, when we're reading in the CSV, it's automatically going to assume it's a comma because it's a comma separated file. You can choose delimiters, headers, names, index columns, and a lot of other things, as you can see right here. Now, I will say that I don't use almost any of these. The few that I'm going to show you really quickly in just a second are up at the very top. But you can do a ton of different things, and I'm just going to slowly go through them. So that's what those are. You can also go down here. This is our doc string, and you can see exactly how these parameters work. It'll show you and give you a text and walk you through how to do this. Again, most of these you'll probably never use, but things like a separator could actually be useful. And things like a header could be useful because it is possible that you want to either rename your headers or you don't have a header in your CSV and you don't want it to auto-populate that header. So that is something that you can specify. So for example, this header one, and I'll show you how to do this, the default behavior is to infer that there are column names. If no names are passed, this behavior is identical to header equals 0. So it's saying that first row or that first index, which is like right here, that 0 is going to be read in as a header. But we can come right over here and we'll do comma header is equal to, and we could say none. And as you can see, there are no headers now. Instead, it's another index. So we have indexes on both the x-axis and the y-axis. And so right now we have this 0 and 1 index indicating the first column and the second column. If we want to specify those names, we can say the header equals none. Then we can say names is equal to, and we'll give it a list. And so the first one was country. And what's that second one? Oh, region. So they're right here. That's the first row, but we'll rename it and we'll just say country and region. And when we run that, we've now populated the country and the region. We're just pretending that our CSV does not have these values in it and we have to name it ourselves. That's how you do it. But let's get rid of all that because we actually do want those in there. So we're just going to get rid of those and read it in as normal. And there we go. Now, typically when you're reading in a file, what you need to do is you want to assign that to a variable. Almost always when you see any tutorial or anybody online, or even when you're actually working, people will say df is equal to. df stands for data frame. Again, this is a data frame. In the next video in this series, I'm going to walk through what a series is, as well as what a data frame is, because that's pretty important to know when you're working with these data frames. But we'll assign it to this value. And then we'll call it by saying df and we'll run it. And that's typically how you'll do things because you want to save this data frame. So later on, you can do things like data frame dot, and you can pass in different modules, but you can't really do that. It's not as easy to do it if you're calling this entire CSV and importing it every time. So let's copy this because now we're going to import a different type of file. So now we've been doing read CSV, but we can also import text files. Now you can do that with the read CSV. We can import text files. Let's look at this one. We have the same one. It's countries of the world, except now it's a text file because I just converted it for this video. I'll copy that as a path. And so now when we do this, oops, let me get those quotes in there. It'll say world.txt. It will still work. As you can see, this did not import properly. We have this country \t region. And then all of our values are the exact same with this \t. That's because we need to use a separator. And I'll show you in just a little bit how we can do this in a different way. But with that read CSV, this is how we can do it. We'll just say SEP is equal to, we need to do \t. Now let's try running this. And as you can see, it now has it broken out into country and region. We could also do it the more proper way, and this is the way you should do it. And I'll get rid of these really quickly, but just want to keep them there in case you want to see that. But you can also do read_table. And let's get rid of this separator. And now we have no separator. It's just reading it in as a table. Let's run this. And it reads it in properly the first time. This read table can be used for tons of different data types, but typically I've been using it for like text files. We can also read in that CSV. So let's change this right here to CSV. We can read it in as a CSV, but just like we did in the last one, when we read in the text file using read CSV, this read table, you're going to need to specify the separator. So I'll just copy this and we'll say comma, and now it reads it in properly. Again, you can use that for a ton of different file types, but you just need to specify a few more things if you don't want to use the more specific read_ function when you're using Pandas. Now let's copy this again. We're going to go right down here. And now let's do JSON files. JSON files usually hold semi-structured data, which is definitely different than very structured data like a CSV where it has columns and rows. So let's go to our File Explorer. We have this JSON sample. We will copy this in as the path. Let's paste it right here. And we'll do read_JSON. Again, these different functions were built out specifically for these file types. That's why, each one has a different name. So now we're reading this in as the JSON. Let's read it in, and it read it in properly. Now let's go ahead and copy this and take a look at Excel files, because Excel files are a little bit different than other ones that we've looked at. So let's just do read_Excel. And let's go down to our file explorer, and let's actually open up this workbook. As you can see, we have sheet 1 right here, but we also have this world population, which has a lot more data. Let's say we just wanted to read in sheet 1. We can do that, or by default, it's going to read in this world population because it's the first sheet in the Excel file. Well, let's go ahead and take a look at that. Let's get out of here. And let's say, oops, I forgot to copy the file path. Let's go ahead and copy as path, and we'll put it right here. And let's just read it in with no arguments or anything in there, or no parameters. When we read it in, it's reading in that very first sheet. So this is the one that has all of the data. Now let's say we wanted to read in that extra sheet name or the second sheet name. We'll just go comma sheet underscore name, say is equal to, and then we can specify sheet, was it sheet 1 like this? Yes, it was. So we just had to specify the sheet name right here. And then it brought in that sheet instead of the default, which is the very first sheet in that Excel. Now that definitely covers a lot of how you read in those files. Again, you can come in here and hit Shift Tab and this plus sign and take a look at all the documentation. And you can specify a lot of different things that I didn't think were very important for you guys to know, especially if you're just starting out. The ones that we looked at today are what I would say are like the ones that I use almost all the time. So I wanted to show you those. But if you're interested in any of these other ones, or you have very unique data and you need to do that, it's worth really getting in here and figuring things out. A few other things that I wanted to show you just in this kind of first video or this intro video on how to read in files. One thing that you may have noticed, especially in this file right here, is we're only looking at the first 5 and then the last 5. So if we wanted to see all the data is in these like little 3 dots right here, right? We want to be able to see that data, but right now we can't. And that's because of some settings that are already within Pandas. And all we need to do is change that. So this one has 234 rows and 4 columns. So obviously we can see all the columns. Well, let's just change the rows. All we'll say is pd.set_option. Now, what we need to do is we're going to change the rows. We're not going to change the columns, at least not on this one. So we'll say, quote, display.max.rows. Now, if we just run this, for whatever data we bring in, it's going to be able to show the max rows. And then we'll say 235, although there's 234 rows, I'm just going to be safe. Let's run this. And now it has changed it. So let's read in this file again, and you'll see how it's changed. Now we have all of the numbers, and we have this little bar on the right that allows us to go down all the way to the bottom and all the way to the top. So now we can actually look and kind of skim and see our values. I like that better than just having that, shorter version. We can do the exact same thing on columns as well. So if we look at this one, this is our JSON file. It has the same thing right here. We have, 38 columns, but we can only see, I think maybe it's 20 or something like that. I can't remember. But we have 38. We can only see let's say 15 of them or 20 of them. We'll do the exact same thing. And we'll just say pd.setOptions.max.columns. And we'll set that to 40 for that one. When we run this, let's get over here. When we run this one again, we can now scroll over and see every single one of our columns. Now that one is in my opinion, a lot more useful. I like being able to see every single column. So definitely something that you should be using, especially when you have these really large files. You want to be able to see a lot of the data and a lot of the columns. So when you're slicing and dicing and doing all the things that we're about to learn in this Pandas series, you know what you're looking at. I also want to show you just how to kind of look at your data in these data frames as well. So that's also pretty important. So let's go right down here. And the very last one that we imported was this one right here, this read Excel. So this data frame is the only one that's going to read in. Let's run it. This is the last one to be run. So this variable right here, df, it won't be applied to all these other ones, which we can always go back and change those. Typically, you'll do something like data frame 2 You want to do something like that. So let's keep data frame 2. Oops. So what we're going to do is we're going to bring data frame 2 right down here. And we want to take a look at some of this data. We want to know a little bit more about it. Something that you can do is data frame 2.info, and we'll do an open parentheses. And when we run this, it's going to give us a really quick breakdown of a little bit of our data. So we have our columns right here, rank, CCA3, country, and capital. It's saying we have 234 values in those columns. Because there's 234, scroll up here, because there's 234 rows, that tells me that there's no missing data in here, at least not, completely missing like null values. There is something in each of those rows. The count tells me it's non-null, so there's no null values, and it tells me the data type. So it's reading in as an integer, an object, and an object. And it also tells us how much memory it's using, which is also pretty neat because when you get really, really large data types, memory usage and knowing how to work around that stuff does become more important than when you're working at these really small, sample sizes that we're looking at. We can also do, oops, let me get rid of that. We can also do data frame 2, and we'll do shape. And for this one, we do not need the parentheses. And all this is going to tell us is we have 234 rows and 4 columns. We're also able to look at the first few values or rows in each of these data frames. So we can just say data frame 2.head. And if we do that, it's going to give us the first 5 values, but we can specify how many we want. We can say head 10. It'll give us the first 10 rows right here. We can do the exact same thing. And let's go right down here and we'll say tail. So they'll give us the last 10 rows within our data frame. Now let's copy this. And let's say we don't want to actually look at all of these values or all of these columns. We can specify that by saying df2 and oops, let's get rid of all of this. And we'll say, with a quote, we'll say rank. And now we can take just a look at the rank data. Now we can't do that by doing the index, or at least not like this. If we want to use this index that is right here, we can, but there's a very special function called loc and iloc for that. And I'm going to have an entire video on this because it does get a little bit more complex. But there's df2.loc, and there's loc and iloc, stands for location and ilocation. That's only for the indexes, whether it's the x-axis or the y-axis, those are the indexes. And for location, it's looking for the actual text, the actual string of the index. So if we come up here, that data frame 2, we can specify 224, and it'll give us this information right here in a little different format. So let's go bracket, and we'll say 224. And when we run this, it gives us our rank, CCA, country, capital with our values over here, kind of like a dictionary almost. Now let's copy this and we'll say df2.iloc. And right now these look the exact same, but we haven't really talked a lot about changing the index, and you can change the index to a string or a different column or something like that. And we'll look at that in future videos. The iloc looks at the integer location. So even if these let's go right up here. Even if this index had changed to, let's say, this rank or this CCA3 or country or whatever you make this index, the iloc will still look at the integer location. So that 224 would still be 224, even if it was Uzbekistan. So then when we look at this, it's going to be the exact same. But if we had changed that index, this LOC is the one that we could search on, and we could search Uzbekistan. Is that how you spell Uzbekistan? Hey, I nailed it. So that is how you use loc and iloc. Again, I just wanted to show you a little bit about how you can look at your data frame or search within your data frame. Hello, everybody. Today, we're going to be looking at filtering and ordering data frames in Pandas. There are a lot of different ways you can filter and order your data in Pandas, and I'm going to try to show you all of the main ways that you can do that. So let's kick it off by importing our data set. So we're going to say data frame is equal to, and we'll say pandas, and I need to import my pandas. So we'll say import pandas as PD. That's pretty important, I think. So pd.read_CSV, and we'll do R, and then we'll say the world population CSV. So let's run this. All our data frame right here. And this is the data frame that we're going to be filtering through and ordering in Pandas. So let's kick it off. The first thing that we can do is filter based off of the columns. So the data within our columns. So Asia, Europe, Africa, or whatever data we may have in that column. Let's go right down here. We're going to say df, and then within it, we're going to specify what column we're going to be filtering on. So we're going to say df with another bracket, and we'll say rank. So we're going to be looking at this rank column right here. And then we'll say in that rank column, we want to do greater than 10. And that's actually going to be a lot of them. Let's do less than. So when we run this, it's only going to return these values that are less than 10. We can also do less than or equal to, all of these comparison operators. So less than or equal to. So now we have all of the ranks 1 through 10. Now, if we look at these countries, we can specify by specific values, almost exactly like we did here. But instead of doing a comparison operator like we did right here and including those names, let's say Bangladesh and Brazil, we can use the is_in function, almost like an in function in SQL if you know SQL. So let's go right down here and we're going to say specific underscore countries. So right now we're just going to make a list of the countries that we want. And then we'll say Bangladesh and Brazil. So let's go right down here. And we'll say, okay, for these specific countries from the data frame, let's do our bracket. We'll say in this country column, so we'll do data frame and then another bracket for country. So in this country column, we can do dot is in and then an open parentheses, and then look for our specific countries. So we're looking at just this column and we're saying is in. So we're looking at are these values within this column? And we're getting this error, and this looks very, very odd. Let me, this doesn't look right. There we go. I just had some syntax errors. I apologize. Made it way more complicated than it needs to be, but here's how you use this is_in function. So we're looking at Bangladesh and Brazil, and we return those rows with Bangladesh and Brazil. Really quickly, I wanted to give a huge shout out to the sponsor of this entire Pandas series, and that is Udemy. Udemy has some of the best courses at the best prices, and it is no exception when it comes to Pandas courses. If you want to master Pandas, this is the course that I would recommend. It's going to teach you just about everything you need to know about Pandas. So huge shout out to Udemy for sponsoring this Pandas series, and let's get back to the video. We can also do a contains function, kind of similar to is_in, except it's more like the like in SQL as well. I'm comparing a lot of this to SQL because when you're filtering things, my brain always goes to SQL. But in Pandas, it's called the contains. So let's actually copy this because I don't want to make the same mistake again. Let's do that and we'll do the bracket. But instead of dot is in, we're going to do dot string dot contains and then an open parentheses. So we're going to be looking for a string. If it contains, let's do United, almost like United States or any other United. So let's run this. And as you can see, we have United Arab Emirates, United Kingdom, United States Virgin Islands. So we can kind of search for a specific string or a number or a value within our data or within that column of country. Now, so far, we've only been looking at how you can filter on these columns. We can also filter based off of the index as well. And there's two different ways you can do it, or two of the main ways. There's filter, and then there's loc and iloc. Loc stands for location, and iloc stands for integer location. And if you've seen other previous videos, I've kind of mentioned those, so we can take a quick look at all of those. So really quickly, we need to set an index because the index right now is not the best. We'll set our index to country. So let's say df2 is equal to df.set underscore index, and we'll say country. Now I'm just doing df2 because later on I want to use that data frame again. So I'm just going to assign it to another data frame so that we can just easily switch back and forth. So now we have this index as the country, and what we can do is use the filter function. So let's go down here. We'll say df2.filter. And we'll do an open parentheses. And now we can specify our items. So these are actually going to be specifying which columns we want to keep. So we're going to say items is equal to, then we'll make a list. We'll say continent. Hope that's how we spell continent. I'm always messing up with my my stuff here, my spelling. Then we'll do CCA3 because why not? You can specify whichever ones you want. When we run this, it's going to only bring in those 2 columns. Now, by default, it's choosing the axis for us, but we can also specify which axis we want to search on. So if we say axis is equal to 0, it's actually going to search this axis. This is the 0 axis. This is the 1 axis. So where our columns are is 1. So if we go back and do 1, we're searching on that 1 axis or those header axes again. And this is the default, but you can specify that. So if you just want to search on, filtering right here, you can do that. And let's actually copy this and do that right down here, just so you can see what it looks like. But let's search for Zimbabwe, and we'll do Zimbabwe, and we'll be looking at the 0 axis, which is the up and down on the left-hand side. And when we filter on that, we can filter by Zimbabwe by looking just at the country index. We can also use the like, just like we did before. And I'll show you the exact same demonstration that we did, which you can say like is equal to, and instead of having to put in a concrete text, you can just say united, just like we did before. And we're searching where the axis is equal to 0, which again is this left-handed axis. So now we're looking for united, and it's going to give us all of the countries or all the indexed values that have united in it. Like we were talking about before, we also have loc and iloc. So we can say dataframe2.loc. Now this is a specific value. So we'll do United States. So location is just looking at the actual name or the value of it, not its position. So if we search for United States, it's going to give us this right here, where it gives us all of the columns for United States and then all of the values for United States. Or we can do the iloc, which is the integer location, which is not the exact same because we're looking at the string for the loc. We're looking at this string, but underneath it, there still is a position. That's that integer location. Let's do a completely random one. Let's just say 3. If we look at the third position, it's going to give us ASM, which I'm not exactly sure what it is, but it still gives us basically the same kind of output, which is the columns and the values. So that's another way that you can search within your index when you're actually trying to filter down that data. Now let's go look at the order by. And let's start with the very first one that we looked at. Let's do data frame. That's why I kept it, because I wanted to use it later. Now we can sort and order these values instead of it just being kind of a jumbled mess in here. We can sort these columns however we would like, ascending, descending, multiple columns, single columns. And let's look at how to do that. So we'll say data frame, and then we'll do data frame, look at rank again, just like we were doing above. And let's do data frame where it's less than 10. I should have just gone and copied this. I apologize. So now we have this data frame that is greater than 10. Now we can do dot sort underscore values. And this is the function that's going to allow us to sort everything that we want to sort. So we can do by is equal to, and we'll just order it by the exact same thing that we were doing or calling it on. So we'll do rank. So now what this is going to do, it's going to order our rank column. And as you can see, it did that 1, 2, 3, 4, 5. We can also do it with ascending or descending. So if you want to, you can look in here and see what you can do. So we'll do ascending. We'll say that's equal to true. And so that's the automatic default. So that didn't change anything. But if we say false, it's going to be descending from highest to lowest. So now we have it in the opposite direction. Now we don't have to just order or sort this on one single column. We can do multiple columns. And we can do that by making a list right here. Whoops, make a list just like that. And we'll input different ones as well. So now let's input our country. And when we run this, it will give us rank of 9876, as well as the country of Russia, Bangladesh, Brazil. Now, if you noticed, the country really didn't change because the rank stayed the exact same. That's because there's an order of importance here, and it starts with the very first one. If we change this around and we look at this one and put a comma right here, now the country is going to be descended and the rank would come second. So it's not going, the rank isn't going to really have any effect here. So now we have the country, United States, Russia, Pakistan, and the rank really didn't get ordered at all. Now, if we want to see how that can actually work, let's do continent right here and actually put it right here and do country here. So if we run this, it's first going to come and it's going to organize or sort the continent. Then it's going to come back and go to the country, and then it's going to sort the country. So keep your eye right here in this Asia area, because we're going to sort this differently than ascending. So we have ascending false, and that applies to both of these. It's false and false, but we can specify which one we want to do. We can do a false here and a true here. So we'll do false, comma, true. And what this is going to do is it's going to say false for the continent. So the continent right here is going to stay the exact same. And so that is a lot of how you can filter and order your data within Pandas. Hello everybody. Today we're going to be looking at indexing in Pandas. If you remember from previous videos, the index is an object that stores the access labels for all Pandas objects. The index in a data frame is extremely useful because it's customizable, and you can also search and filter based off of that index. In this video, we're going to talk all about indexing, how you can change the index and customize that, as well as how you can search and filter on that index. And then we're also going to be looking at something a little bit more advanced called multi-indexing. And you won't always use it, but it's really good to know in case you come across a data frame that has that in it. So let's get started by importing pandas. Import pandas as PD. Now we'll get our first data frame. We'll say df is equal to pd.read_csv. And I've already copied this, but we're going to do R, and we're going to put this file path. So I have this world population CSV. I will have that in the description, just like I do in all of my other videos. Let's run df, and let's take a look at this data frame. So we have a lot of information here. We have rank, country, continent, population, as well as the default index from 0 all the way up to 233. Now, if you haven't watched any of my previous videos on pandas, the index is pretty important, and it's basically just a number or a label for each row. It doesn't even necessarily have to be a unique number. You can create or add an index yourself if you want to, and it doesn't have to be unique, but it really should be unique, especially if you want to use it appropriately. For what we're doing, the country is actually going to be a pretty great index because the country is going to be all unique, because we're looking at every single row as a different country, as well as the population. So let's go ahead and create this country or add this country as our index. Now we can do this in a lot of different ways, but the first way that you can do this, if you already know what you are going to create that index on, is we can just go right in here when we're reading in this file, and we'll say comma, index underscore, oops, I spelled that completely wrong, index underscore column, and we'll say that is equal to, and then we're going to say quote country. So we're taking this country and we're going to assign it as the index. Now let's read this in. And as you can see, this is our index. Now it looks a little bit different. We didn't have this country header right here, which is specifying that this is still the country. But you can tell that this is the index based off the bold letters, as well as it being on the far left. And all the regular columns for the data is over here, while the country header is right here, and it's lower than all the others. Just a quick way that you can see that that is the index. Now, before we move on, I want to show you some other ways that you can do this as well. But I'm going to show you how to reverse this index before we move on. And we'll say data frame. So we had our data frame right here. So we have data frame dot, and we'll say reset underscore index. And then we'll say in place is equal to true, which means we don't have to assign this to another variable and all that stuff. It'll just be true. So now when we run that data frame again, the index was reset to the default numbers. So now let's go down here, and I'll show you how to do this in a different way. You can do df dot, we'll say set underscore index, and then we'll just say country. So very similar to when we were reading in that file and we said set the index, or that index column, we said index column equals country. If we do this and we run it in, it works. But if we say data frame right down here, it's not going to save that. If we want to save it, just like we did above, we're going to say in place is equal to true. That is going to save it to where we don't have to assign it another variable. So now when we run this, the data frame right here, which is going to populate this, the data frame is going to say in place is equal to true. So that country will now be our index again. Let's run this. And there we go. Really quickly, I wanted to give a huge shout out to the sponsor of this entire Pandas series, and that is Udemy. Udemy has some of the best courses at the best prices, and it is no exception when it comes to Pandas courses. If you want to master Pandas, this is the course that I would recommend. It's going to teach you just about everything you need to know about Pandas. So huge shout out to Udemy for sponsoring this Pandas series, and let's get back to the video. Now, what's really great about this index is we're able to search based off just this index. And so we can filter on it and basically look through our data with it. And there are two different ways that you can do that. At least this is a very common way that people who use Pandas will do to kind of search through that index. The first one is called lock, and there's lock and iLock. And that stands for location or integer location. Let's look at lock first. Let's say df.lock, and then we'll do a bracket. Now we're able to specify the actual string, the label. So let's go right up here and let's say Albania. So we'll say Albania. So again, this is just looking at the location. Let's run this. Now it's going to bring up all the Albania data, just like here, where it kind of looks like a column in a column. And we can get this exact same data, but using iLock right here. And when we ran lock, we were searching based off Albania, which is in the 0, 1 position. So if we actually pull the 1 position for that integer, the iLock, we can look at the 1 position, and this should give us the exact same data. Now let's take a look at multi-indexing, and we'll come back to a little bit of this in a second. So multi-indexing is creating multiple indexes. We're not just going to create the country as the index. Now we're going to add an additional index on top of that. So let's pull up our data frame. Right now we have the country, but let's do dot reset index, and we'll say in place equals true. Oops. Let's run it. So now we have our data frame. Now let's set our index, but this time when we set our index, we're going to add the country as the index as well as the continent as an index. So we'll say data frame dot set underscore index. Then we'll do a parentheses, and instead of just doing country like we did before, we're going to create a list. Oops, and we'll do it like that. And then we'll say continent, and separate it by a comma. So we have continent and country. Let's just say in place is equal to true. Now, when we run this, we're going to have 2 indexes. Let's see what this looks like. And let's run this. So now we have country as well as continent as our index. Now you may notice that these indexes are repeating themselves on this continent index. We have Europe right here and Europe right here, as well as Asia and Asia. And it looks a little bit funky, but we are able to sort these values and make it look a lot better. So let's go ahead and try this. We'll do df.sort underscore index. And when we run this, it should sort our index alphabetically. And we can also look in here and see what kind of things we can, specify. We can specify the axis, but it's automatically going to be looking at the 0. This is 0 and this is 1. So we have 2 axes within our data frame. You can choose the level, whether it's ascending or not ascending, in place, kind, string, sort remaining, all of these different things. The only one that I really, think is worth looking at is the ascending. We already know some of these other ones. But if we look at ascending, let's run it. Now it's sorted these, and so now it's kind of grouped together. So we have Africa and all the African ones, as well as South America and all the South American ones. Let's really quickly say pd.set underscore option, and we'll say display.max.columns, and just like this, let's run it. And I need to specify right here. Let's see how many rows we have. 235. So let's do 235. Let's run this. And now when we run this, you can see that Africa is all grouped together and all the countries are in alphabetical order under it. And then we go all the way down to Asia. And again, just all in alphabetical order. If we wanted to, we could say ascending equals true. And then when we run this, I meant to say false. And then when we run this, it's the exact opposite. So it starts with South America, the last one, and then goes in reverse alphabetical order. We could also say false, make it a list and do comma true. and just like this. And then it would sort this first column as false and this next column as true. So you can really customize it, but you know, for what we're doing, we don't need any of that. We just need to be able to see this right here. So now when we try to search by our index like we did before, we did dataframe.loc. Now when we did that and we said, you know, let's say Angola, when we specified Angola, it's not going to work properly because it's searching in this first index for the first string that we have. We can search Africa. Let's search for Africa. And now we have all of the African countries. And if we want to specify to Angola, we can also go down another level, by doing Angola. And now we have what we were looking at before, where we're calling all of the data within those, but we couldn't do it just based off Africa because we had an additional index right here. So once we called both indexes, now we get this view. But let's look at that iLoc really quick. When we run this, let's just say 1, because right up here, we have Angola 0 and then 1. So you think it may pull up Angola. Let's go ahead and run this. And it's still pulling up Albania. Let's go right up here. If you remember, when we didn't have the multiple indexes, it was pulling up Albania. The difference when you're doing these multi-indexes is that the loc is able to specify this, whereas this one does not go based off that multi-indexing. It's going to go based off the initial index or the integer-based index. So that's a lot about indexing in Pandas. We'll cover even a few more things in future videos as we get more and more into Pandas. But this is a lot of what indexing looks like within Pandas. And again, super important to learn how to do and know how to do because it's a pretty important building block as we go through this Pandas series. Hello everybody. Today we're going to be taking a look at the group by function and aggregating within Pandas. Group by is going to group together the values in a column and display them all on the same row. And this allows you to perform aggregate functions on those groupings. So let's start reading in our data and take a look. So we're going to do import pandas as PD. And then we're going to say our data frame is equal to, and we'll say pd.read_CSV. We'll do an open parentheses, R, and our file path. And we're going to be looking at the flavors CSV right here. So right here we have our flavor of ice cream. We have our base flavor, whether it was vanilla or chocolate, whether I liked it or not, the flavor rating, texture rating, and its overall or its total rating. Now, these are all my own personal scores. So, you know, I've spent years researching this. So these are all very accurate, but this should be a low stress environment to learn group by and the aggregate functions. So the first thing that we can do is look at our group by. Now, you can't group by, well, you can group by flavor, but as you can see, these are all unique values. What we need is something that has duplicate values or similar values on different rows that I'll group together. So this base flavor is actually a perfect one to group it on. And we'll do that by saying df.group by, do an open parentheses, and we'll just specify base flavor. And this will then group together those values. And I need to make sure I can spell properly. This will group those flavors together. So let's run this. And as you can see, it actually is its own object. So it has a group by, data frame group by object. So now that we've grouped them, let's give it a variable. So we'll say group underscore by underscore frame. Let's say that's equal to, let's copy this. We'll run it. And now what we need to do is run our aggregations in order to get an output. So we're going to say dot mean, and that's all we're going to put just for now, just to get an output that we can take a look off, and then we'll build from there. So let's go ahead and run this. And right here, we have our base flavor, which is now saying is the index of chocolate or vanilla. And then it's taking the mean or the average of all the columns that have integers. Notice that it did not take the liked column and it did not take the flavor column because those are strings and they cannot aggregate those. And we'll take a look at that later. But it took all the values that have integers and then it gave us the average of those ratings. Really quickly, I wanted to give a huge shout out to the sponsor of this entire Pandas series, and that is Udemy. Udemy has some of the best courses at the best prices, and it is no exception when it comes to Pandas courses. If you want to master Pandas, this is the course that I would recommend. It's going to teach you just about everything you need to know about Pandas. So huge shout out to Udemy for sponsoring this Pandas series, and let's get back to the video. So right off the bat, as averages, with chocolate, I have a much higher rating overall than the ones with vanilla bases. Now we can actually combine all of this together into one line, and we can do something like this. So we'll say df.groupby, and we'll say .mean, just like this. And this will actually run it. Before, we didn't have any aggregating function on there, so it didn't run. But now that we combine it all into one, it will run properly. Now there are a lot of different aggregate functions, but I'm going to show you some of the most popular ones or the most common ones that you will see. So let's copy this right here. So we can do .count. And when we run this, we can look at the count. And this will show us the actual count of the rows that were aggregated. So for chocolate, we had 3. So there's going to be 3 all the way across. And for vanilla, we had 6. So we're looking at a higher count of vanilla, which if you're comparing it to this mean up here, that could be a big skew towards the chocolate, because if you have 1 or 2 good chocolates, it could really pull the numbers up. Whereas if you had 2 good vanillas, but all the other ones were bad, it pulls that average down. So knowing the count of something is really good. Let's take a look at the next one, and we can do min and max, and I'll just run these really quickly. We can do min, and when we run this, the first thing that you should notice is that it now has a flavor and a liked column. And that's because min and max will actually look at the first letter in this string, or the first set of letters if there are, chocolate something. It'll look at the first, and then it'll actually populate it. So chocolate with the CH chocolate is the very first, or the minimum value for that string. And for cake batter, that is the minimum value in vanilla as well. Now with the liked, it's interesting because apparently I liked all the chocolate ones. I'm gonna go take a look. So chocolate, I liked, chocolate, I liked, chocolate, I liked. So there is no option in this liked column. So yes was the only option. And now let's look at max, whoops. And it should do the exact opposite, which is going to take the highest value, even if it's a string. So Rocky Road, the letter R comes later in the alphabet. So that's what it's looking at. And so does vanilla. And then we have yes as well. And then of course, right here, it's taking the max value. So before when we were looking at min, I just focused on those, but it still does the exact same thing to these integer columns as well. So for the max value for vanilla, it was mint chocolate chip. That was our base. So I had a rating of 10 for this vanilla row or grouping. And then we can also look at the sum. And there are all the sums for these. And again, it only does integer because we can't add the strings. But here are the sum, or the total values for all of them. And for the total values, since we had 6 rows that we're grouping into this vanilla, we now have a lot, or a much higher score for vanilla. Now that's a really simple way to do your aggregations, but there is actually an aggregation function. And let's take a look at this, because this is a little bit more complex, although when I write it out or show you, hopefully it makes a lot of sense. We can do .agg. So this is our aggregate function, and what we need to pass into our aggregate function is actually a dictionary. So let's do an open parentheses, and we're gonna do a squiggly bracket. And then we need to specify what we're gonna be aggregating on, or what column. So let's do this flavor rating. Let's copy this. We'll do flavor rating, and I need to put that as a string. And then we'll do a colon. And now we can specify what aggregate functions we want. So we've done sum, count, mean, min and max, all of those. And we can actually put all of those into here and perform all of those aggregations on just one column. So let's make a list. And then let's say mean, max, count, and what's another one? Sum. So let's do all 4 of those only on this flavor rating column. And when we run this, we have our base flavor right here, chocolate and vanilla. But now we don't have multiple columns. We have one column with multiple columns of our aggregations. And it is possible to pass in multiple columns like that. So we'll do texture rating. And we'll just come right here and do a comma. Then we'll say texture rating. And then a colon. I don't know why I spelled it out when I copied it, but I did. And then we'll do the exact same ones. And now when we run it, we're getting the exact same columns, mean, max, count, and sum for flavor rating, then mean, max, count, and sum for our texture rating. Now, so far, we've only grouped on one column, but we can actually group on multiple columns. Let's go back up here to our data. And I should have just copied this down here. Let's go back down and just look at this. So really, we only grouped it on this base flavor. But you can do multiple groupings or group by multiple columns. So let's do our base flavor, which we did already, as well as the liked column. So we're going to say df.group by, then we'll do an open parentheses. And then instead of just passing through one string, we're going to do a list, and we'll say base flavor, comma, and then we'll do liked. So now when it groups this, it should put two groupings, and let's run this and just see. I got to say, let's just do .mean. So now we have our chocolate and a vanilla. And remember, chocolate only had yes, so that's the only one that it's going to group on. But vanilla had a no and a yes. So if we look at the vanilla, we have our base flavor vanilla, and then within liked, we have no and a yes, which can show us that within our vanilla, when we group on these, our no's were really low, but our yeses were really high. We actually had a pretty similar rating or very close to the same rating as the ones we really liked in chocolate. And just like we did above, we can take this .ag, and I'm going to copy this, and it'll perform it on each of those rows. Let me close that. And what did I do wrong? Oh, I need the squiggly bracket. And it'll show us each of those, so the mean, max, count, and sum for all of the chocolate and vanilla, as well as the groupings of liked, yes, and no. Now, after we've looked at all that, and that's how I usually do it, there is one shortcut function that can give you some of these things just really quickly. And so let's go back up here and take this. It's just called describe. And if you've ever done it, it's just going to give you some high level overview of some of those different aggregations. So let's run this, and it's going to give us our chocolate and vanilla. And within each column, it's going to give us our count, our mean, our standard deviation, I believe is what that is, our minimum, 25%, 50, 75, and 100, which is our max, then our count and our mean. So a lot of those aggregate functions, but the describe is, a very generalized function. We can't get as specific as we were with the previous ones that we were looking at. But I just wanted to throw this out there in case this is something that you'd be interested in, because it, technically is showing a lot of those aggregate functions just, all at one time. So hello everybody. Today we're going to be talking about merging, joining, and concatenating data frames in Pandas. This whole video is basically around being able to combine two separate data frames together into one data frame. These are really important to understand when we're actually using the merge and the join. Right here we have what's called an inner join. And the shaded part is what's going to be returned. It's only the things that are in both the left and the right data frames. Then we have an outer join or a full outer join. And this will take all the data from the left data frame and the right data frame and everything that is similar. So basically it just takes everything. We also have a left join, which is going to take everything from the left. And then if there's anything that's similar, it'll also include that. And then the exact opposite of that is the right join, which is going to give us everything from the right data frame, and it's going to give us everything that is similar, but it's not going to give us anything that is just unique to the left data frame. So this is just for reference, because in a little bit when we start merging these become very important. So I just wanted to kind of show you how that works visually. So let's get started by pulling in our files. So first we're going to say import pandas as PD. We'll run this. And then we'll say data frame 1, and we'll also have a data frame 2. And these are the different data frames, the left and the right data frame, that we'll be using to join, merge, and concatenate. So we'll say data frame 1 is equal to pd.csv_read, and we'll do R, and here is our file path. So we have this lotr.csv, that's our Lord of the Rings CSV, and let's call that really quickly so we can see what's in there. And I'm having a dyslexic moment because it's supposed to be read_CSV. I apologize for that, but this is our data frame. This is our data frame 1. We have 3 columns. It's their fellowship ID, 1001, 2, 3, and 4, their first name, Frodo, Samwise, Gandalf, and Pippin, and their skills, hiding, gardening, spells, and fireworks. So this is our very first data frame that we're going to be working with. Let's go down a little bit. Let's pull this down here. And we're just going to say data frame 2, and this is the Lord of the Rings 2. So let's pull this one in now. As you can see, it's very similar. We have fellowship ID 1, 2, 6, 7, 8. So we have 3 different IDs here. We don't have 6, 7, and 8 in this first data frame. We also have the first name. So Frodo and Sam, or Samwise, are in the very first and the second data frame. But now we have 3 new people, Boromir, Elrond, and Legolas. And now we have this age column, which again is unique to just this second data frame. First one that I want to look at is merge. And I want to look at merge first because I think this one is the most important. I use this one more than any of the ones that we're going to talk about today. The merge is just like the joins that we were just looking at, the outer, the inner, the left, and the right. And there's also one called cross, and I'll show you that one, although if I'm being honest, I don't really use that one that much, but it's worth showing just in case you come into a scenario where you do want to do that. So let's go right down here, and I want to be able to see these while we do it. So we're going to say data frame 1, and when we specify data frame 1 as the very first data frame, we say data frame.merge, this is automatically going to be our left data frame. Then if we do our parentheses right here and we say data frame 2, this is our right data frame. And let's see what happens when we do this. So what it's going to do, and this, we didn't specify this, it's just a default, it's going to do an inner join. So it's only going to give us an output where specific values or the keys are the same. Now you can't see this, but what is happening is it's taking this fellowship ID and saying I have 1001 here, a 1002 here. This is the exact same as up here with this fellowship ID and fellowship ID of 1001 and 2. But when we look at 1003 and 4, those aren't in this right data frame, and 6, 7, 8 is not in this left data frame. So the only ones that match are this 1001 and 2, and that's why they get pulled in down here. But because we didn't explicitly say, here's what I want to join or merge between these 2 data frames, it actually is looking at the fellowship ID and the first name. So it's taking in these unique values of Frodo and Samwise, which are the same in both, which is why it pulled it over. But really quickly, let's just check and make sure that we did it on the inner join, because again, we didn't specify anything, that was just the default. So we're gonna say how is equal to, and then we'll say inner. And if we run this, it's gonna be the exact same, because again, the inner is the default. But now, just to show you how it's kind of joining these 2 data frames together, I'm going to say on is equal to, and then I'm only going to put fellowship ID. So let's run this. Now, the first thing that you may have noticed is this first name underscore X and this first name underscore Y. What the merge does as kind of a default is when you are only joining on a fellowship ID, we have this right data frame with fellowship ID, the left data frame with the fellowship ID. If you're just joining on these and you're not joining on the first name and the first name, then it's going to separate those into an underscore X and an underscore Y. And even though they have the exact same values, since we are not merging on that column, it automatically separates that into 2 separate columns so we can see the values within each of those columns. If we went into this on and we make a list, and let's do it like that, and we say comma, and then we write first name, first name, and then we run this, it's going to look exactly like it did before. Again, it automatically pulled in both of these columns when it was merging it the first time, even though we didn't write anything. But if we actually write this, it's doing exactly what it was doing when we just had df2. We're just now writing it out. Now, there are other arguments that we can pass into this merge function. Let's hit Shift Tab, and let's scroll down here. So within this merge function, we have a lot of different arguments that you can pass into it. First, we have this right, which is the right data frame, which is this data frame 2. Then we have the how and the on, which we've already shown how to do. There's a left on, left index, right index. Not something you'll probably use that much, but you definitely can if you want to look into that. And there's all these doc strings which show you exactly how to use all of these. So if you're interested in looking at the left and the right and the left index, it's all in here. But one that is really good is the sort, and you can sort it saying either it's false or true. Then we have these suffixes. Now, if you remember, when we took these out, what it automatically did was it put in these underscore X and underscore Y. You can customize that and you can put in whatever you'd like. Instead of the _x and _y, you can put in some custom string for that. We also have an indicator and a validates. Again, all things that you can go in here and look at. I'm just going to show you the stuff that I use the most. So these things right here are things that I definitely use the most. So now that we've looked at the inner join, let's copy this right down here and let's look at the outer join. And these get a little bit more tricky. I think the inner join is probably the easiest one to understand. Let's look at the outer. It's spelled O-U-T-E-R. I don't know why I always want to say O-U-T-T-E-R, but let's run this and see what we get. So now this looks quite different. The inner join only gave us the values that are the exact same. This one is going to give us all of the values regardless of if they are the same. So we have 1, 2, 3, 4, 6, 7, and 8. So let's scroll back up here. So we have 1, 2, 3, 4, 1, 2, and 6, 7, and 8. So we don't have a 1005. And then if you notice in this data frame right here, if the value doesn't have, so if we can't join on the fellowship ID or the first name, like Legolas wasn't one that we joined on, or that has a similar value in the left data frame, it just gives us an NaN, which is not a number. And it's going to do that for any value where it couldn't find that join or it couldn't match something within that either ID or first name. So in age, we also have that for the ones that weren't in the right data frame. We only had 1001 and 1002. So we'll have the age for both Frodo and Sam. But for Gandalf and Pippin, we don't have their corresponding IDs. And so it's just going to be blank for Gandalf and Pippin. And you can see that right here. So again, outer joins are kind of the opposite of inner joins. They're going to return everything from both. If there is overlapping data, it won't be duplicated. Now let's go on to the left join. And I'm going to pull this down right here. And now we're just going to say how is equal to left. And let's run this. So what this is going to do is it's going to take everything from the left table or the left data frame right here. So everything from data frame 1. Then if there is any overlap, it'll also pull the overlapped or the, whatever we're able to merge on from data frame 2. So let's go back up to our data frame 1 and 2. So it's going to pull everything from this left data frame because we're specifying we're doing a left join. So everything from the left data frame will be in there. We're also going to try to bring in everything from the right, but only if it matches or is able to merge. So just this information right here will come over. We weren't able to join on 1006, 1007, or 1008. So really none of that information is going to come over. So let's go down and check on this. So again, we have 1, 2, 3, 4, all of the data with this first name and skills, everything is in here. But then we are trying to bring over the age, but we only have matches with 1001 and 1002. So only these two values will come in. Let's look at the right join because it's basically the exact opposite. Let's look at the right. And this is basically the exact opposite of the left in the fact that now we're only looking at the right hand. And then if there's something that matches in data frame 1, then we will pull that in. So this is basically just looking like data frame 2, except we're pulling in that skills column. And since only 1001 and 1002 are the same, that's why the skills values are here. Now, those are the main types of merges that I will use when I'm using a data frame or when I'm trying to merge a data frame. But there also is one called a cross or a cross join. And let's look at this one. And this one is quite a bit different. Here we go. Let's run this. So this one is different in that it takes each value from the left data frame and compares it to each value in the right data frame. So for Frodo in this left data frame, it looks at the Frodo in the right data frame, Samwise in the right data frame, Legolas, Elrond, and Boromir all in the right data frame. Then it goes to the next value, Samwise, and does the exact same thing. Frodo, Samwise, Legolas, Elrond, Boromir. And it does that for every single value. So let's go right back up here. So it's taking this 1001, and it's comparing it to 1, 2, 3, 4, 5. Then it's taking Samwise, and it's comparing it to 1, 2, 3, 4, 5. Gandalf, 1, 2, 3, 4, 5, Pippin, and then you kind of see that pattern. And that's what a cross join is. There are very few, in my opinion, reasons for a cross join. Although if you ever do like an interview where you're being interviewed on Python, you will sometimes be asked on cross joins. but there aren't a lot of instances in actual work where you really use or need a cross join. Now let's take a look at joins. And joins are pretty similar to the merge function, and it can do a lot of the same thing, except in my opinion, the join function isn't as easily understood as the merge function. It's a little bit more complicated, but let's take a look and see how we can join together these data frames using the join function. So let's go right up here. We're going to say data frame 1 dot join, and then we'll do data frame 2. Very similar to how we did it before. And let's try running this. And it's not going to work. When we did the merge function, it had a lot of defaults for us. Let's go down and see what this error is. It says the columns overlap, but no suffix was specified. So it's telling us that it's trying to use the fellowship ID and the first name, just like the join did, except it's not able to distinguish which is which. And so we need to go in there and kind of help it out a little bit. Again, a little bit more hands-on than the merge, but let's see what we can do to make this work. Let's do comma, and we'll say on, and let's open this up and kind of see what we have. So this one has less options than the merge does. We have other, and that's our other data frame. We can do on, and we're going to specify, what column do we want to join on? And then we can look at how do we want it to be a left, an inner, and outer, the same kind of types of joins as the merge. Then we have that left suffix, right suffix. And that's right here is kind of part of the issue that we were just facing, is that those columns are the same. But if we say left suffix, it'll give us an underscore, whatever we want to specify, any string. 4 columns that are both in the left and the right, we can give it a unique name, so we'll no longer have that issue. And then we can also sort it like we did on the other one. But anyways, let's go back to our on. We'll say on is equal to, and then we'll say fellowship ID. Let's try running this. And we're still getting an error. It's just not as simple as the merge. So let's keep going. So now let's specify the type. So we'll say how is equal to, and we'll do an outer. And if we run this, it still doesn't work. We're still getting the exact same issue as the left suffix and the right suffix. So now let's finally resolve it. I just wanted to show you how a little bit more frustrating it was. But now let's say L suffix is equal to, and now it automatically, when we did the merge, did an underscore X, but we can do, let's do underscore left, and then we can do a comma. We'll do right suffix, and we'll say is equal to, and we'll do underscore right. Now, when we run this, it should work properly. Let's run this. So this is our output, and obviously it looks quite a bit different. Over here, we have this fellowship ID. But then we also have fellowship ID left, first name left, fellowship ID right, and first name right. So it just doesn't look right. Now, something I didn't specify when I first started this, because I kind of wanted to show you, is that the join usually is better for when you're working with indexes. Before, when we were using the merge, we were using the column names, and that worked really well and is pretty easy to do. But as you can see right here, when we're trying to use these column names, it's not working exceptionally well. Let's go ahead and create our index, and then I can show you how this actually works and how it works a little bit better when we're working with just the index. Although you can get it to work just the same as the merge, it's just a lot more work. So let's go right down here, and let's go and say df4, so we'll create a new data frame. We'll say df1.set_index, and we'll do an open parentheses. And we'll say we want to do this index on the fellowship ID. And then we're going to do the join. So now we're going to say join. So we're setting an index. So we're setting that index on the fellowship ID. Now we're going to join it on df2.set_index. And then we're also going to do that on the fellowship ID. And I'll just copy this. Oh, geez. I hate it when I do that. Okay. Now we also want to do and specify the left and the right index. So I'll just copy this because we do need to specify this. Now let's try running the data frame 4. So really quickly, just to recap, we were setting the indexes. We were doing the same thing above, right? We have this join. We were joining data frame 1 with data frame 2. Now we're joining data frame 1 with data frame 2, except in both instances, we're setting the index as fellowship ID. So we're joining now on that index. So now let's run this. And this should look a lot more similar to the merge than the join that we did above. except now the fellowship ID right here is actually an index. So it's just a little bit different, but we can still go in here and do how is equal to outer. Oops, let's say outer. So we can still specify our different types of joins or the different way that we can merge or join these data frames together. We can still specify that. Again, it's just a little bit different. And that's why for most instances, I'm using that merge function because it's just a little bit more seamless, a little bit more intuitive. The join function can still get the job done, but as you can see, it takes a little bit more work. Now let's look at concatenate. Concatenating data frames can be really useful, and the distinction between a merge and join versus the concatenate is that the concatenate is kind of like putting one data frame on top of the other, rather than putting one data frame next to one another, which is like the merge and the join. So concatenating them is just a little bit different in how it'll operate, but let's actually write this out and see how this looks. Let's go up here and we'll say pd.concat, we'll do an open parentheses, and then we're gonna concatenate data frame 1, data frame 2. That's all we have to write, and let's run this. And so just like I said, it literally took the first data frame 1, 2, 3, 4 and put it on top of the right data frame 1, 2, 6, 7, 8. So that is our left data frame, this is our right data frame, and they're literally just sitting one on top of the other. But just like when we merge either with a left or a right, when you have these skills and there aren't any values that populate for them, it is going to say not a number. And since we're not actually joining, we're not joining on 1 and 2, even though this 1 and this 1 is the same rows, it's not populating that value because, again, we're not joining these together. We're just concatenating and putting one on top of the other. Now, if we go into this concat, we say shift tab, there are a lot of different things that we can do, which if you remember, the 0 axis is the left-hand index, and the axis of 1 is the top index, which is the columns. So you can specify that. And we can also do joins. And this is the one that I'm going to take a look at, but there are other ones that you can look into as well. Let's look at join. Let's do comma, and we'll say join is equal to, and let's do an inner join. So let's see what happens with this. As you can see, it is only taking the columns that are the same. That's what this inner is doing. It's joining these columns together. And the ones that were different, they didn't take because, again, we weren't able to combine them. They aren't similar between both data frames. Let's do an outer. And now it's going to take all of them. And like I said, that's doing this on these columns right here, but we can also do it on this axis as well. So let's go ahead and say axis is equal to 1. And when we run this, now it's joining us on this index right here of 0, 1, 2, 3, 4. So now these ones are being joined together. And it's putting it side by side, much like a merge would. So that's how concatenate works. And I'm going to show you one more thing. And again, it's not up here in this title because it's not one that I recommend, but it's one called append. The append function is used to append rows from one data frame to the end of another data frame. And then we can return that new data frame. And so let's do data frame 1 dot append. We'll do an open parentheses and we'll say data frame 2. Very similar to how we've been doing other things. And let's run this. And as you can see, this is almost exactly like how the concatenate did when we first did it. But if we read kind of this warning, it's saying the frame.append method is deprecated and will be removed from Pandas in the future version. Use pandas.concat instead. So it's literally warning us, append is on its way out. If you want to do exactly what you're doing right here, go and try concat or concatenate because that'll do the exact same thing. So I'm not really going to show you any other variations of append because there's no reason it's going to be on its way out in the next version. So that is our video on merge, join, and concatenate, and append as well, in Pandas. And I hope that was helpful. I hope that you learned something. I mean, this stuff is really important because oftentimes you're not just working with one CSV or one JSON or one text file, you're working with multiple of them, and you need to combine them all into one data frame. And so this is a really, really important concept and thing to understand. Hello, everybody. Today, we're going to be building visualizations in Pandas. In this video, we'll look at how we can build visualizations like line plots, scatter plots, bar charts, histograms, and more. I'll also show you some of the ways that you can customize these visualizations to make them just a little bit better. With that being said, let's go right over here, start importing our libraries, and we'll start with importing Pandas as PD. And this one is really all you need to actually create the visualizations in Pandas, but we may get a little bit crazy. And so we're going to do a few different ones as well, like import numpy as NP, and then we're going to do import mat matplotlib.pyplot as PLT. Now I may or may not use this. I just, when I get into visualizations, I may want to change some different things. So we're going to at least have them here in case we do want to use them. Let's go ahead and run this. So now let's get our data set that we're going to be using. So let's say data frames equal to pd.read_CSV. And let's get this in right here. Now we're going to be doing these ice cream ratings. Let's take a look at this really quickly. Now these values are completely randomly generated. They are not real in any way, but that's what we're going to be using because I just wanted something kind of generic, something that wouldn't be too crazy confusing, just something that we could use and you guys can understand that they're just numerical values. But let's also set that index really quick. So we'll say dataframe.set_index, and then we'll say date. And then we'll say that's equal to the data frame. And we have this date column right here as our index. So we have January 1st, 2nd, 3rd, 4th, and then we have our ratings right here. And again, these are all just integers and they're pretty easy or really easy to demonstrate how you can visualize these. So that's why we're using it today. So the way that we visualize something in Pandas is we use something called plot. So let's just take our data frame. We'll do dataframe.plot and we'll do our parentheses. Now let's go in here really quickly. Let's hit Shift Tab, and this is going to come up, and this is pretty important, because this kind of is going to tell us what we can do within this plot. And unfortunately, there isn't like a quick overview. We just have this doc string, but we have our parameters right here. These are what we can pass in to kind of customize our visualization. So the data is going to be our data frame. Then we have our X and Y labels. We can specify the kind, and this one's important because we can specify what kind of visualization do we want. We can do a line plot, horizontal, a vertical bar plot, histogram, box plot, and then a few others, including area, pie, density, all these other things. We can also specify if we want it to be a subplot. And a lot of these things that I'm specifying, I'm going to show you how to do. You can use different indexes. You can add titles, add grids, legends, styles, all these different things. And you can go through here because there are a lot. But you can specify and customize all of these things. We won't be going into all of them, but I will show you some of the ones that I probably use the most and that I think are the most useful to know right away. So let's get out of here. And we're just going to do df.plot. And when we run this, we'll get this right here. And that was super, super easy. We created a line plot by literally doing just about nothing. But by default, it's going to give us a line plot. So if we come up here, we say kind, and let me get that out of the way, is equal to line, and we run this. So by default, without us actually having to input anything, it's giving us that line plot as a default. So we can specify that it's a line plot. As you can see, we already have all of our data right here. We didn't have to specify anything. It kind of automatically took it in. It is visualizing all three of these columns. And it has this little legend right here. And we can specify where we want that. There is an argument to be able to do that. It also gave us these tick marks of 2, 4, 6, 8, 10. Again, it read in and said it's only going from 0.0 to 1.0. That is kind of the peak. And so it kind of automatically gave us these ticks for us. Again, that's another thing that you can specify. We make it go up to 2, 5, 10, 1,000, whatever you want it to be. And then we're doing this based off of this date value right here. Really quickly, I wanted to give a huge shout out to the sponsor of this entire Pandas series, and that is Udemy. Udemy has some of the best courses at the best prices, and it is no exception when it comes to Pandas courses. If you want to master Pandas, this is the course that I would recommend. It's going to teach you just about everything you need to know about Pandas. So huge shout out to Udemy for sponsoring this Pandas series, and let's get back to the video. If we wanted to break these out by the actual column, we could go in here and say subplot is equal to true. And it's actually subplots, whoops. And now we can run that. And then we can see each of those columns being broken out by themselves instead of them all being in one visualization. It's now 3 separate visualizations. Now let's go right over here. We're gonna get rid of the subplots. I wanna show you just some of the different arguments that you can use to make this look nice because I don't wanna do this on every single visualization. I just wanna show you what you can do. So we have this one right here. We can add a title. Notice there's no title or anything really telling us what that is. So we can say comma, title, and we'll say ice cream ratings. If we run this, we now have this nice title right here. Now we can also customize the labels or the titles for the X and Y axis. It automatically took this date, which is right here. This is our date index. It automatically took that for us, but we can customize that if we'd like to. All we have to do is comma, and then we'll say X label is equal to, and so our X is this date one right here. And we can say daily rating. And then we can do the Y label. We'll say Y label is equal to, and for this one, we can say scores. I hope you cannot hear my dog in the background because they are being insane. But let's go ahead and run this. And now we have these daily ratings on the X-axis, and on the Y-axis, we have scores. Now let's go right down here and start taking a look at our next kind of visualization, which is going to be a bar plot. So we'll do df.plot. We'll do kind is equal to, and for this one, we're going to say bar. Now this is what your typical bar plot will look like, and a lot of the arguments that we just did on the line plot, you can also apply to this bar plot. Something that's unique to the bar plot is that you can also make it a stacked bar plot. All we have to do is go in here, we'll say comma, and we'll say stacked is equal to true. So now it's going to make it a stacked bar chart instead of just, your regular bar chart. Let's go ahead and run this. And as you can see, this is now stacked on top of one another with each of these columns all representing the values that they have. Now we don't always have to do every single column. We can also specify the column that we want. So let's take the flavor rating, for example. We could do flavor rating, good night, flavor rating. And then it's only going to take in that flavor rating column. And if you notice, we don't have a legend. That's only when you have multiple values, which we are only looking at this one column. So all the values are right here. Now in this bar chart, it automatically defaults to a vertical bar chart, but you can change it to a horizontal bar chart. Let's go ahead and take a look at how to do that. Bring back all of them. We'll do df.plot dot, and then we'll say bar h. And I don't know if I can keep in that kind equals bar. Let me run this. Yeah, I need to get rid of that because the bar.h is its own, this is its own function. So now I'm going to run this. It should just have a stacked bar chart, except now it should be horizontal. So now you can see this worked properly. It's basically the exact same thing as a vertical bar chart, just now horizontal, which may look better, especially depending on if you have values like this, or something else that just looks better being horizontal. Now the next one that we're going to take a look at is the scatter plot. So we're going to say df.plot.scatter, and if we run this, we're going to get an error. What we need in order to run this properly is we need to specify the X and the Y axis in order for this scatter plot to work. So let's go here and we'll say X is equal to, and we can take any of our columns that we have up here. So we'll say X is equal to texture rating, and then Y is equal to, we'll do overall rating. Now when we run this, it should work properly. Let's go ahead and take a look. Now if we go in here and we do Shift Tab, we can also see some other things that we can specify. So let's go right down here. So we have our X and we have our Y, and those are the ones that we just did. We can also pass through an S, which is going to tell us or change the size of the actual dots right here in our scatter plot. Then we can also do a C, which is the color of each point. Let's start with the S. Let's say S is equal to, and let's just do 100. Let's see what that looks like. So we have a much larger number. Let's do 500 and see what that looks like. So we can make these much larger on our visualization, depending on what you're looking for. We can also look at the color. Let's put comma C. So for color, we can say color is equal to, and let's do yellow. Let's see if this works. So now we've changed it to yellow. That looks absolutely terrible, but it does work. Now let's move on to the histogram. Histogram is always a good one. It's very similar to something like a bar chart. But what's great about a histogram is you can specify the bins. So let's go ahead and say df.plot.hist. Then we'll do an open parentheses, and let's go ahead and hit Shift Tab in here. Take a look at this one as well. So some of our parameters are the actual columns or the data frames that we want to pull in. We can choose the bins, and they have a default of 10 in here. And so let's take a look at how this works. So we'll just run this as it is. So this is by default what this histogram is going to look like. Let's go ahead and specify our bins. We'll just say it was 10 by default. Let's just do 20, see what that looks like. So there are smaller columns right off the bat. And remember, histograms are really good for showing distribution of variables. That's really what a histogram is for. But of course, since these are completely random numbers, this histogram isn't going to make any sense at all, but you can at least kind of see visually how it works. And if I didn't mention it before, which I should have, the bins represent how many kind of tick marks are down here. So if we just do 1, it's only going to be one very large, histogram. We could even go further down from 10 and do 5. So now there's only 1, 2, 3, 4, 5. So the distribution gets smaller and things get more compact. As you spread it out, again, like we did 100, it's going to spread it out a lot. And this is what it shows. It's showing the distribution of those bins across however many you want. So the 10 by default, it usually is pretty good for a lot of different things. Now let's go down here and look at the box plot. And the box plot is a pretty interesting one. Let's go ahead and visualize it really quickly, and then I'll kind of explain how this one works. So let's do df.boxplot. Let's run this. And really what we're looking at is some different markers within our data. This line right here is the minimum value within that column. We also have the bottom of the box, which is the 25th percentile of all the values within just this column. This is 50%, then we have 75%, and then up here, we have our maximum value. So I can take a glance at this and see that we have a low minimum, a high maximum, and it definitely skews towards the lower range. Whereas if I look over here, we have a lower minimum and a higher maximum. And you can see that this medium point is at 0.6 versus 0.4 over here. So this skews a lot higher. Now let's go down here and take a look at an area plot. We'll do df.plot.area. And let's just run this. This is what we're going to get by default. Now, something I wanted to show you earlier, I just haven't gotten around to. I want to show you something called figure size or fig size. So for this, it just looks small, looks a little bit cramped. Let's say we want to increase the size of this. And we'll say fig size is equal to, and let's just do a parentheses and say 10, 5. That should be pretty large. And this is going to make it a lot larger. Just something I wanted to throw in there. But I look at these area charts as pretty similar to like a line chart. If we went and compared those, this would be pretty similar. But they're different visually, and you absolutely can use these for different types of visualizations. But I don't use this one a lot, if I'm being honest. That's why it's kind of towards the end of the video, but you definitely can do it. Let's go on to our very last one of the video. That's going to be the beautiful pie chart. Let's say df.plot.pie. We'll do an open parentheses, and let's run it. We're going to get this error. That's because we need to specify what column we're working with here. So let's just say the Y, and that's what we need. Let me open this up for us. Right here, we have our Y, and this is our label or our column that we're going to plot. That's really all we need. So we can just say Y is equal to flavor rating. Flavor rating. And let's run this. And now we get this visualization right here. Let's make this one a little bit bigger. Fig size is equal to 10, 6. Now it's a little bit bigger. It definitely depends. So this legend is going to auto-populate. You can make this as big as you want. And obviously it's going to look a little bit better if you do it larger. And these colors auto-populate. Now you can customize these colors, although I found these ones to be just, when you have a lot of them, it's harder to customize them as easily. But, definitely look into it. These are things that everything in here is almost something that you can customize in some way. Although it does get a little bit tricky, you definitely have to do some research and some Googling around just to kind of figure out how to do those things. Now, one last thing that I wanted to show, and something, I could have probably done at the beginning, is you can actually change what visual this is. And we can do that pretty easily. Within Matplotlib, there are different styles. And so let's go right here. Let's add a new row, a new cell, and we'll say print, and we'll do PLT. So that's that Matplotlib right here. We'll do PLT.style.available. And what this is going to do, what this is going to do is show us all these different types of stylings that you can do to kind of change up this visualization. And then once we find the one that we like, we'll just do PLT.style.use, And then in the parentheses, we'll just specify which one we want. Now, there's all these Seaborn ones, and Seaborn is a really great library. Let's try Seaborn Deep. I haven't tried this one at all. Let's go ahead and try this. And just changes some of the colors, some of the visuals. We can try something like 538. Let's try this. That looks quite a bit different. And let's try something like Classic. I don't know what this one looks like. Let's just try it. So you can try out all these different styles, find one that you like, find one that you think looks really nice, and you can run with it through all your visualizations. Hello everybody. Today we're going to be cleaning data using Pandas. Now there are literally hundreds of ways that you can clean data within Pandas, but I'm going to show you some of the ones that I use a lot and ones that I think are really good to know when you are cleaning your data sets. So we're going to start by saying import pandas as PD, and we're going to run that. And now we're going to import our file. So we're going to say data frame is equal to PD, so that's pandas.read underscore, and we actually have this in an Excel file. So we'll say read, say read Excel, do an open parentheses, and we'll do R, and then we'll paste the path right here. And now we're just going to call that variable. So we'll call data frame, and we'll actually read it in and look at the data. So let's scroll down here, and let's take a look at this data frame or this Excel file that we're reading in. So right off the bat, we have this customer ID that goes from 1001 all the way down to 1020. We have this first name, and everything looks pretty good here, except in this last name column, looks like we have some errors. We have some forward slashes, some dots, some null values. So definitely gonna have to clean that up because we don't want that in the data. We have a phone number. And it looks like we have a lot of different formats, as well as NAs, not a number, just lots of different stuff. So we're going to need to standardize that. So clean it up and then standardize it to where it all looks the same. We also have address, and it looks like on some of these we just have a street address, but on some of the other ones we have like a street address and another location, as well as a zip code in some of them. So we'll probably want to split those out. We have a paying customer, which is yes and no's, and some of those are not the same, so I'll have to standardize that. We have a do not contact, kind of the same thing as the paying customer. And we have this not useful column, which we'll probably just want to get rid of. Okay, so the scenario is that we got handed this list of names, and we need to clean it up and hand it off to the people who are actually going to make these calls to this customer list. So they want all the data in here standardized and cleaned so that the people who are making those calls can just make those calls as quickly as possible. But they also don't want columns and rows that aren't useful to them. So things like this not useful column, we're probably going to get rid of. And then ones that say do not contact, if it says yes, we should not contact them, we probably will want to get rid of those somehow. So that's a lot of what we're going to be doing to clean this data set. Normally, the very first thing that I do when I'm working with a data set, most of the time, except very rare cases when you're actually supposed to have duplicates, is I actually go and drop the duplicates from the data set completely. All you have to do for that is say df.drop_duplicates. So they make it super easy for you. Let's just run it. And up here is our original data set. We have this 19 and 20, and those are obviously duplicates. They have the exact same data. It's just a duplicate row that we need to get rid of. If we look right down here, we no longer have that 20. We now just have one row of Anakin Skywalker. And of course, we want to save that. So we're just going to say df is equal to and df. So now it's going to save that to the data frame variable again. And now when we run this, our data frame now does not have any duplicates. That's definitely one of the easier steps that we're going to look at. Things are going to get quite a bit more complicated as we go, but I'm starting out, kind of simple so that we can kind of get a feel for it. And then we'll start getting into the really tough stuff. So the next thing that I want to do is remove any columns that we don't need. I don't want to clean data that we're not going to use. So if we're just looking through here, they may need, first name, last name, phone number for sure. Address might give them some information of where they're calling to or time zone, so we want that. This not useful column looks like a pretty good candidate to delete. And it's very easy to do that. We're going to go right down here, and we're going to say df.drop. We'll do an open parentheses. Drop just means we are dropping that column. And we can specify that by saying columns is equal to, and then we'll paste in that column that we want to delete. So let's run this and see what it looks like. And it literally just drops that column exactly like we were talking about. It no longer has that column. Again, we want to save that. We can always do in place equals true. If you follow this tutorial series, you can always do in place equals true, and that'll save it as well. But just for our workflow, most of the time, I'm going to assign it back to that variable just for keeping it the same. Really quickly, I wanted to give a huge shout out to the sponsor of this entire Pandas series, and that is Udemy. Udemy has some of the best courses at the best prices, and it is no exception when it comes to Pandas courses. If you want to master Pandas, this is the course that I would recommend. It's going to teach you just about everything you need to know about Pandas. So huge shout out to Udemy for sponsoring this Pandas series, and let's get back to the video. Now let's kind of go column by column and see what we need to fix. And we'll start on this left-hand side. This customer ID to me looks perfectly fine. I'm not going to mess with it at all. The first name at a glance also looks perfectly fine. I don't see anything wrong with it visually, which is a good thing. Although sometimes that can be deceiving and it can cause errors down the line, but we're not going to assume that there are errors in here. Now let's look at this last name. Now the last name, obviously, I'm seeing some obvious things that we talked about when we were first looking at this data set. We have this /, which we definitely need to get rid of. We have null values, so not a number right here. We have some periods as well as an underscore right here. So all those things, I think we should clean up and get rid of it so that when the person is making these calls, it's all cleaned up for them. So how are we going to do that? We can actually do this in several different ways, but let's just copy this last name. The first one I'm going to show you is strip, and we'll write it kind of like this. We'll say data frame, and then we'll specify the column that we're working with because we don't want to make these changes or strip all of these values from everywhere. We only want to do it on just this column. If we do this and we don't specify the column name, it will apply it to everywhere. So if we're trying to do these, let's say these underscores, maybe that would mess with something else in another column, and we don't want that. So we just want to specify just this last name. So let's go last name dot string dot strip. Now what strip does, and let's see if we can open this up really quickly. No, we can't. But what strip does, I was hitting Shift Tab in here to see if it could bring up, some of the notes on it. But what strip does is it takes either the left side or the right side. Well, L strip takes from the left side, R strip takes from the right side, and strip takes from both. But you can strip values off the left and the right hand side, and we can specify those values. Now, for what we're doing in this column, we can just use strip because as you can see, this /, these dots, as well as this underscore are all on the far sides. If there was a value like swan underscore son, the strip wouldn't work at all because it's not on the outside of the value or the word. So we can use strip. I'll also show you how to use replace, and replace is another really good option for things like this. But let's start with strip and just see what it looks like and see if we can get what we need done. So let's just run this for now and see what happens. So it looks like nothing has changed because again, we're not specifying any specific value. Just by default, it's only taking out white space. So like spaces that shouldn't be there. That's what it does by default. Now we can specify within this exactly what values we want to take out. So let's go ahead and do that. Let's say left strip, and let's try to take out these dots real quick. So we're just going to do a parentheses, ... Now let's run this and see what it looks like. For this one, Potter, it is now gone. So those 3 dots were there before. Let's just show it. So they were there. And then when I ran it like this, now they're gone. That's what the L strip does. It takes it only off the left-hand side. Now we can also do a /. So we'll do something like this, and it'll get rid of the white. But as you can see, now we aren't taking out these 3 dots, so they're still there. Now, is it possible to do something like this, where we put these values inside of a list? Let's try it. So we'll say just like this, 1, 2, 3. Let's run it. And no, it doesn't. This L strip actually sits within the realm of regular expression. So if you've ever worked with regular expression, you know it gets very complicated, very complex. So you want to keep it kind of simple, especially with these values where we're just taking a few out. So what we're going to do is we're going to do ... and we're going to take it out one by one. Now, in order to save this, because we want to save this, we want to take out that value. We don't just want to say data frame equals, because that would be Very bad. What this would say is now this data frame is only equal to these values that we're seeing right here. We want to only apply it to this column. So we're going to go like this. So now when we do it, and then we call the entire data frame, it's only applying this to this one column, the last name column. So let's run it. And now when we go down to Potter right here, it's cleaned up. So we're going to do the same thing, but for those other values. And we'll do it just like this. We'll do a / and it's a left strip. And then I'll do the left strip on this underscore just to show you that it won't work. And then we will go on from there. So it's not pulling it because we're looking at the left-hand side only. We need to use R strip. So now let's use R strip. And now that looks perfect. It has no underscore. So that's how you can use strip for either the left side, the right side, or just strip by itself, which covers both sides. Now I showed you all of that because I am going to show you a different way to do it. And I apologize because I somewhat lied to you earlier. Let's run this right here. Actually, we're just going to pull it in like this. We're going to remove the duplicates again. Bear with me. We're going to drop that column. And then now we're sitting with that data frame again with those exact same mistakes. I just wanted to reset it for a second. There is a way that you can do this. And I just wanted to, kind of show you how you can do it. You can do this right here. And we'll say, so we're just looking at this column, and we're using strip. And let's get rid of R because we want to apply it to everywhere. You can input all of those values individually and it will clean it up. So let's say we want to get rid of numbers. We'll do 1, 2, 3. Then we could do the dot. So that's going to be for our period or for our ... Potter. We could also do the underscore and we can do the /. So we put it all in one string right here. Now let's take a look at this. We'll get rid of this really quickly. Now let's take a look and all of them were removed. I showed you how to do it before because that's at least how my mind would think about it. I'd think, oh, I can put it in a list and run it through this L strip or this right strip and it would work. But that's not how strip works. You have to kind of combine it all into one value. So yes, I deceived you. I apologize. But now when we call data frame and we assign it to that column, so the last name column, we're assigning what we just did to this last name column, everything should look perfect. And it does. So our customer ID, first name, last name are all cleaned up. Now we're going to come to a much more difficult one. This is probably, if I'm being honest, the hardest one. I said we were going to work up, but this is probably the hardest one of the whole video, working with phone numbers. And look at all these different types of formats. I mean, it is, it's not going to be fun. And imagine, there's 20,000 of these. You can't just go and manually clean those up. You need something to kind of automate that. So that is what we're going to do. So let's go right down here. We'll copy the data frame and I'm going to pull it right here. So now we need to clean up this phone number. What we want is it all to look exactly the same, unless it's blank, and we'll keep it blank. We don't want to populate that data, but we want all of them to look exactly like this one. And what we're going to do is right off the bat, we're going to take all of the non-numeric values and just completely get rid of them. Strip it down to just the numbers. So this 123-643 or / will just be the numbers. Same with these bars and these slashes and everything. All of these will just be numeric. Then we'll go back and reformat it how we want to format it, which will look exactly like this one. But we just want to do it for the entire column. So let's go right up here and we're going to try replace for the first time. So let's do phone number. Do it just, oops, that's not what I wanted. So we're going to do a bracket. Let's say phone number dot string dot replace, just like we did before. Now we're going to use some regular expression in here, and I'll kind of do a really high overview, although I'm not going to dive super deep into the regular expression. Then we're going to do a parentheses, and within there, we're going to do a bracket. I can't remember what this is called. Is it called a caret? I think it's called a caret. But I'm just going to call it that. It may not be correct, but I think it's an upper arrow. So it's an upper arrow, A-Z, A-Z, and then 0-9. Now at a super high level, what that caret or that first thing is doing, it's saying we're going to return any character except, and then we specify anything A to Z, upper or lowercase. And then actually, I think this should be like this, A to Z, and then 0-9. So any value like A, B, C, 1, 2, 3, those are not going to be matched. It's going to match all of them except these values. And then we're going to replace them by saying comma, and we're going to replace them with nothing. So this is just an empty string. So literally we're taking everything that is not an A, B, C, a 1, 2, 3, so a letter or a number. We're replacing all of that, and then we're replacing it with nothing. So let's run this and see what it looks like. And it looks like that worked properly. Now we do have this NA because we had an N-A for, I don't know, maybe that was Creed Breton. But it worked for basically everything else. We're going to go through the entire process, and then at the end, we'll remove any values. We want them to just be completely null. We don't want them to even see NaN and wonder what that is. We just want it to be blank. And we'll do that at the very end. So now that we know that that worked, let's assign it. We'll do df phone number is equal to, and then we'll say data frame. And this looks a lot more standardized than it did before already. But now what we want to do is try to format this. And I've done this many, many times. I always use a lambda. You can definitely use a for loop. I don't do it that way myself. So I'm going to show you how to do it using a lambda. Let's get rid of this. And we're going to say df phone number. We've already done that. I'm just going to get rid of it. We're going to say df phone number. Then we're going to say dot apply. We'll do an open parentheses. And then this is where we're going to build out our lambda. So we'll say lambda x colon. Now this is where we're going to kind of format it. So what I want to do is I want to take the first 3 strings, 1, 2, 3. Then I want to add a slash, and then the next 3 strings, add a slash or a dash, and then that be the value that's returned. So it's not super difficult. We're just going to do x, and then a bracket. Let me get rid of that. An x, and then a bracket. And then we want the 0 to 3. So it goes 0, 1, 2. So 0, 1, 2. It doesn't include the 3. It goes up to 3. So 0, 1, 2. That's our first 3 values. Then we'll do plus and do a quote and do a dash. So this is our first kind of sequence. And I'm just going to copy this. And we'll do plus. And instead of 3, we are going to start at 3 because now it's inclusive. So we're going to go from 3 and we're going to go all the way up to 6. So it should be 3, 4, 5, our next 3 values. And then we have a dash, and we'll copy this and we'll say plus. And now we go from 6 all the way to 10. Now let's try running this. And as you can see, we get an error. Now I already know what the error is. Float object is not subscriptable, which means we're trying to basically look at it like a string. Right now, it's not a string. It's actually a number. So let me get rid of this for just a second. I want to show you what it's talking about. So right now, we have values that are floats and values that are strings or not even a number. So we have values that are strings or not a number. So if we want to actually look through it, like kind of like indexing, if we want to do that, they all have to be strings. So we need to change this entire column into strings before we can apply this formatting. Now, when I was creating this, if I'm being honest, my first thought when I was doing this was to do it like this: string df phone number. Let's just run that. This is what the values look like. And I don't remember why it was doing this. I can't remember, but I looked into it quite a bit and I was like, oh, I need to apply this string, converting it to a string on each value, not the entire row or not the entire column. So how we can do that is actually fairly easy because we've already done a lot of the heavy lifting. We're just going to copy this and we're going to say x, so string of x. And again, lambda is like a little anonymous function. So you could do this by saying for x in this column, we could do a for loop and then say for every x, it equals the string of x, and then it changes it to a string. But a lambda just does it a lot quicker. So we're going to say, so let's do that really quickly. And all of our values look exactly the same, and that's how we want it. So we're just going to copy this, apply it, Good. And now we're going to take this and we're going to run this again. Just ignore all my commented out stuff. Pretend I don't have that. So now when we run this, it should work. There we go. Now, if we look at these numbers, 123 dash 545 dash 5421, and it does that for every single one where there's values, even when there's NaN or Na, it's still adding those values, but we expected that. So let's apply it, say is equal to, and then we'll look at the data frame. And this looks almost exactly what we're hoping for. We just need to get rid of these. So this NaN dash dash and this Na dash, we need to get rid of those. And that is super easy to do. We're just going to say, so now that we've done it, and we'll comment that out, we'll say df, and let's copy this. Ignore the messiness. I do apologize for that. It's very messy. But if you're following along with me, you get what we're doing. So df phone number, so only on the phone number, say dot string dot replace, and open parentheses. Now we can specify this value. So we want to take this exact value and replace it with nothing. And let's just see if that does work. It does. Now we have these NAs. And so let's actually, I'll paste that right down here. We're going to do this is equal to, and then we're just going to take this entire string, put it right here, and put this value as our what we're looking for and then replacing. And then when we call that data frame, it should work properly. And it is perfectly cleaned. So we have every single value, all the exact same. They don't have different characters or different, formatting. And we got rid of all the ones that we don't have or don't need. All the ones that were just random values. So this column is now completely cleaned up. Again, definitely one of the more difficult ones, ones that I've done 1,000 times. I've had to work with a lot of phone numbers and stuff like that. This one does get very tricky, especially if you have like a +1, which is like an area code. That can get tricky as well, but this is on a kind of a high level. This is how you can do that. And it's pretty neat how you can actually, clean up and standardize those phone numbers. So let's go right down here. Let's run it. The next thing that we're gonna look at is this address. Now let's just pretend that the people who are on the call center want all these separated into 3 different columns. They can read it easier, see what the zip code is, where they live, whatever they want it for. Let's just say we want to do that. And this is, again, for this use case, it may not make sense, but you have to do this. I do this all the time. You need to split those columns. Now, luckily, all of these things are separated by a comma. So we can specify that we're going to split on this column, and then we'll be able to create 3 separate columns based off of this one column, which is exactly what we want. And we can name it as well. And we can do that very easily by using this split. So we're going to say df, and we want to specify, oh geez, not again. So we want to specify that we're looking at the address. Then we're going to say dot string dot split. And we'll do an open parentheses. Now the very first value that we need to specify is what we're splitting on. So we want to split on the comma. So we want to specify that. And then we need to specify how many values from left to right it should look for. Now we'll just start with 1 and then we'll go from there. Let's just see what this looks like. So it doesn't really look like it did anything. Let's do 2. Well, let's go back to 1 and then let's say expand equals true. When we expand it, it's actually going to separate it, I believe. Okay, so we're expanding. We're only doing this with 1 comma. So we're only looking at the very first comma and splitting it. But in some of these, well, just in 1, there is an additional comma. So we should do it up to 2. Let's do this. Okay, so now we have 3 columns. If we just save it like this, it's going to give us these 0, 1, 2, basically these indexed values for these columns. And we don't want that. We want to specify what these actually are. And we can do that by saying df, and let me just do is equal to. We'll do bracket, and then within there, we're going to specify our list. So we have 3 of them that we have. So I'm going to do the first one. This is the street address. So we'll say street address. The next one is, it's Shire is not a state, but these all are states. So I'm just going to say state. And then for the very last one, that looks like a zip code. So we'll say zip, and we'll do underscore code. In fact, I also want to do street underscore address. So what this is now going to do is these three columns are going to be applied to these three names, and they'll basically be appended. It doesn't replace the address. We're not saying df address equals the df address. We're not replacing it. We're now creating different columns. So let's run it, and then let's also call it. So they're right over here on this right-hand side. I couldn't see them at first, but it did exactly what we needed it to do. So now if we wanted to, at the very end, if we want to, we're not going to, we could just delete this address and keep the street address, the state, and the zip code. Another really common thing that you can do, this happens often again with like first name, last name, where you'll have Alex Freeberg, but it's Alex comma Freeberg or Alex space Freeberg. And you can separate those out into different columns. Now the next one that we want to look at is this paying customer, and the paying customer and do not contact are very similar in the fact that it's yes, no, NY, yes, no, NY. And so let's go right on down here, and we're going to say df dot, and we want to just replace these values as all yeses or all nos, but just with the same formatting, just to keep it consistent. So let's make anything that's an N into a no, anything that's a Y into a yes. I like it spelled out. So let's change anything that's a yes into a Y, anything that's a no into an N. That's usually how I do it. Just saves on data because it's less strings, although it can be often very minimal. But let's specify the paying customer. We'll say df bracket paying customer. Then we'll do dot string dot replace. So now we're just going to look for those specific values. So if it's a Y, a capital Y, then we'll say yes. Now let's run it. And now we have no more Ys. We now just have yeses, although now these are yeses. Okay, we don't want to do that. Let's do, if we're looking, because it's taking, it's literally looking up here and saying, okay, here's a Y. Let's change that Y into a YES. So now it's doing YES, ES. We don't want that. So let's look for the yes and change it into a Y. Now when we run this, that looks a lot better. So we'll do df paying customers equal to, and then we'll copy this. We'll do the exact same thing. No and N. And then let's call it. And now that entire column looks really good, except for that value right there. But I'm going to leave that because I'm just going to apply it to the entire thing all at once to get rid of those at the end instead of just going column by column. And then it's literally going to be the exact same thing. So I'm not even going to scroll down. Whoops. I'm just going to put it right up here because this is the exact same thing. I'm going to save us all some time. And when we run this, this looks exactly like what we're looking for. Again, some not a number of values, but we can get rid of that in just a second by doing a replace over the entire data frame. And that is basically the end of cleaning up individual columns. Now let's go right down here. We're going to say df.string.replace, and then we'll first do these values. Oops. So we'll do, oops, let me do that. There we go. And replace that with nothing. And let's just see what it looks like. Oops, data frame object has no value string. Well, that's because we were looking at columns before. Yeah, I think I just need to get rid of this string. We're not looking at it. We're just really doing it across the entire data frame. Now let's try that. Okay, that worked appropriately. And we'll just say data frame is equal to, and then we'll copy this and we'll do the NaN as well. And we'll do, and now when we do this, it is not going to replace these because these aren't actually a value because we're looking for that string. We actually need to use, and I completely forgot this. I'm not going to lie to you. Let's get rid of this. To get rid of those values, because it's literally not a number. It is technically empty. I forgot we can do, or we could not even specify it. we'll do df.fillNA. So we're going to fill these values if there's nothing in them. We're going to fill it and we're going to say blank. And when we run that, every value that doesn't have something in it is going to show up blank. Even over here, where we only had a few, all of them throughout the data frame, if it doesn't have a value, it is now blank. So let's apply that. And we'll run this. And now all of our cleaning, for actually cleaning up the individual columns, is completely done. We've removed columns, we've split columns, we've formatted and cleaned up phone numbers. We've also taken values off of first name or this last name column. And then we formatted and just kind of standardized paying customer and do not contact. Now, they also asked us to only give them a list of phone numbers that they can call. So if we take a look, some of these do not contacts are Y, which means we cannot contact them. And then there are some that don't even have phone numbers. So we don't want to give the people, the call center, numbers that or people who don't have numbers. So we want to remove those. Now there's a few different ways that we can do this, but let's start with, and we'll just go by, do this do not contact. It seems like the most obvious one. Now, if it's blank, we want to give them a call. We only want to not call them if they've specifically said we cannot call them. So if it's Y, we're not going to call them. So what we need to do, and I don't know, it's not anything like this, we probably need to loop through this column and then look at each row that has a value of this and drop that entire row. And we probably will need to do that based off this index instead of doing it based off just this column. That may not make sense, but let's actually start writing it. So we'll do 4x in, and we need to look at our index. So we're just going to let's do in df.index, and we'll do a colon, enter. And then we want to look at these indexes. How do we look at these indexes? We use lock. That's going to be df.loc. And then we need to look at the value, which is this X right here. So each time it looks at the index, it's looking at the value. But we want to look at the value of this column. Do not contact. I don't know if I copied this before. Let me copy it. We only want to look at the value in this one column. If we didn't, it would look at a different value. So we don't want that. So we're looking at just that value if it's equal to Y. So if this value is equal to Y, then we want to drop it. So we actually need to say if. So if this value, X, in this column is equal to Y, then we want to do df.drop, and then we'll say X, and I think we have to say in place equals true here, otherwise it won't take effect. Otherwise you have to say like df is equal to df.ai, and I don't want to start messing with that. Let's just do in place equals true. And let's see if that works. I can't remember if this is going to work or not. Invalid syntax. Okay, need a colon. And now let's try to run this. Okay, yeah. If we look at our index, we can already tell that there are ones missing. The one is missing, the 3 is missing. Let's see. And the 18 is missing. So we already got rid of those values, and you can see that there's no Y's in here anymore, which is really good. We can, if we want to, and we probably should. We should probably populate that really quickly. Let me just go up here really quick. I'll copy this. We probably should populate that, and I didn't plan on doing this. So if it's blank, oops. If it's blank, give it an N, and we want to attribute it to do not contact. Do not contact, whoops. Let's see if that works. And we probably need to do dot string. Let's just see if it works. So if it's blank, dude, okay, I don't know why it's giving us a triple N. Maybe I need to strip this or something. Okay, never mind. Let's not do that. But now we basically need to do the exact same thing for this phone number, because if it's blank, we don't want them calling it. So we can copy this entire thing, go right down here. but now we're looking at phone number. So now we're looking just at the values within phone number, and we only want to look at if it's blank. So if it literally has no value, we want to get rid of it. Let's run this and see if it works again. It should. Good. And now our list is getting much smaller. So you can see in our index, a lot of those rows were removed. And okay, good. Actually, this worked itself out because these all have ends. So right now we're sitting really good. Everything looks really standardized, cleaned. Everything looks great. I might drop this address. If you want to, you can drop this address. But besides that, this is all looking really good. This paying customer doesn't, the yes and no's aren't really anything. Now we could, and we probably should, before we hand this off to the client or the customer call list, we probably should reset this index because they might be confused as why there's numbers missing, or, they might use this index to show how many people they've called, or I don't know, something like that. So let's go right down here. We're going to say df dot, and then we'll do reset underscore index. And let's just see what this looks like. It does work, but as you can tell, it didn't get rid of that index completely. It actually took the index and saved that original one. We do not need to save that. Whoops, let's put it right in here. Now we're just going to do drop equals true. And when we do that, it just completely resets. It drops the original index and gives us a new index. And that is what we want. Let's do df equals. And this is our final product. Now, one thing that you definitely could have done here, and I made this a little probably more complicated than it needed to be. That was just how my brain was working at the time when I'm typing this out. We could have done df dot drop NA, which is literally going to look at these null values. Before, we couldn't do that with this one because we're not looking at NA, we're looking at Ys. So we couldn't do that. But because we're looking at null values, we could have also done drop NA and done subset is equal to, and then done it just on this phone number. And then done like this and done in place equals true. So we could have also done this and then said df equals. I can run it. It's just not going to do anything. I can run it on the different column, but that'll mess everything up. But this is another way you can do it. And I'll just save it in case you want to. I'll say another way to drop null values. There you go. And that'll just be a note for us in the future. But this is our final product. It looks a lot different than when we first started. I mean, we had mistakes here, completely different formatting in the phone number, different address, everything that we just talked about. And this looks just a lot better. And you can tell why it's really important to do this process because, again, we're working on a very small data set. I purposely, created this data set with these mistakes because, when you're looking at data that has tens of thousands, 100,000, 1,000,000 rows, these are all things that are going to be applied to much larger scale, and you won't be able to as easily see them. You'll have to do some exploratory data analysis to find these mistakes. And then you're going to need to clean the data, or doing it at the same time when you're exploring the data. So you'll clean it up as you go. But these are a lot of the ways that I clean data, a lot of the things that you can do to make your data just a lot more standardized, a lot more visually better. And then it really helps later on with visualizations and your actual data analysis. So hello everybody. Today we're going to be looking at exploratory data analysis using Pandas. Exploratory data analysis, or EDA for short, is basically just the first look at your data. During this process, we'll look at identifying patterns within the data, understanding the relationships between the features, and looking at outliers that may exist within your data set. During this process, you are looking for patterns and all these things, but you're also looking for mistakes and missing values that you need to clean up during your cleaning process in the future. Now, there are hundreds of ways to perform EDA on your data set, but we can't possibly look at every single thing. So I'm just going to show you what I think are some of the most popular and the best things that you can do when you're first looking at a data set. The first thing that we're going to do are import our libraries. So we'll do import pandas as PD. We're also going to import Seaborn and Matplotlib. Now, During this exploratory data analysis process, I often like to visualize things as I go because sometimes you just can't fully comprehend it unless you just visualize it, and it gives you a larger, broader glimpse of everything. So we're going to import, and let's do seaborn, as SNS, and then we'll import matplotlib.pyplot as PLT. Let's run this. That should work. Okay, perfect. Now we need to bring in our data set. So we've worked with that world population data set. That is the exact one that we're going to use now. So we'll say data frame equals pd.read_CSV. We'll do R, and we'll paste in our CSV. And this is what it should look like, although your path may be different. Be sure to make sure that you have the correct file path. And then we'll read it in. Now this data set should look extremely familiar if you've done some of my previous Pandas tutorials, but I did make some alterations to this one. Took out a little bit of data, put in a little bit of data here and there to change things up, because if it was just exactly how I pulled it, which I got this data set from Kaggle, if it was exactly how we pulled it, like we've looked at in the previous videos, it's too simple. You know, we wouldn't actually be able to do some of the things that I would like to show you. So be sure to actually download this exact data set for this video because it is a little bit different. But what we're going to do now is just try to get some high level information from this. Now, if yours looks just a little bit different, like your values are in scientific notation, I have applied this so many times, I think it's still applied to this. You can do something, and we'll write it right down here. We're going to do pd.set_option. And we'll do an open parentheses, and we'll say display.float_format. And so we're going to change that float format by just saying lambda x : and then we're going to change basically how many decimal points we're looking at. So let's just do here. So we'll do a quote, %, 0.2f. So we're formatting it. 0.2f. So we're going to format it, and we'll do %x. This is going to format it appropriately. I can run it, and actually it will change it because this is at 0.1, because I believe last time I did it. So let's run this, and then let's run this again. It'll change it to 0.2, so that's 2. I like it at 0.1. We don't really need it any, well, let's keep it at 0.2. Why not? We're going to keep it at 0.2, but that's how you change that. And I like looking at it like this a lot better than scientific notation. So just something to point out. Let's go down here. And let's just pull up data frame. So we have this data. One of the first things that I like to do when I get a data set is to just look at the info. So we're going to do .info. And this gives us just some really high level information. This is how many columns we have. Here are the column names. Here are how many values we have. And if you notice, this is where it kind of gets, so we have 234 in each of these. So in each of these columns, we have 234 until we get to this 2022 population. Once we get there, we start losing some values. And then at the world population percentage, we have all of our values, all 234 of them. The count tells us that it's not null, so it does have values in it. And then we also have the data types. And these come in handy later. And these are really great to know. And we'll be able to kind of use those in a few different ways later on in this tutorial. Really quickly, I wanted to give a huge shout out to the sponsor of this entire Pandas series, and that is Udemy. Udemy has some of the best courses at the best prices, and it is no exception when it comes to Pandas courses. If you want to master Pandas, this is the course that I would recommend. It's going to teach you just about everything you need to know about Pandas. So huge shout out to Udemy for sponsoring this Pandas series, and let's get back to the video. The next thing that I really like to do, and this one is df.describe. This allows you to get really a high level overview of all of your columns very quickly. You can get the count, the mean, the standard deviation, the minimum value and the maximum value, as well as your 25, 50, and 75 percentiles of your values. So just at a super quick glance, there is a row somewhere in here, and this country, their population is 510 for 2022. And in fact, if you go back to 1970, it was higher. It was at 752. That's just interesting. Then if we look at the max population, one has 1.42 billion. I believe that's China. And then over here in 1970, we have 822 million. Again, I still believe that's China, but this gives you just a really nice high level of all of these values or all of these different calculations that you can run on it. And we can run all of these individually on even specific columns, but it's just a nice high level overview. One thing that we just talked about was the null values that we're seeing in here. I'd like to see how many values we're actually missing, because that is a problem. We don't want to have too many missing values that could really obscure or change the data set entirely. And so we don't want that. So we'll say df.isNull, and then we'll do a parentheses and we'll say .sum. And when we do this, whoops, .sum, there we go. When we do this, it's going to give us all the columns and how many values we're actually missing. Now we have 234 rows of data. So we have 41477555424. So we definitely have data missing. What we choose to do with it in the data cleaning process, maybe we want to populate it with a median value. Maybe we just want to delete those countries entirely if the data is missing. I don't think you're going to do that, but these are things that you need to think about when you're actually finding these missing values. This is what the EDA process is all about. We want to find different either outliers, missing values, things that are wrong with the data, or we can find insights into it while we're doing this as well. So this is definitely something that I would consider when I'm actually going through that data cleaning process. Really, really important information to know. Now let's go right down here, go to our next cell, say df.unique. And this is going to show us how many unique values, and it's actually n unique. This is going to show us how many unique values are actually in each of these columns. And this one makes the most sense for continent, because I think there's only 7 continents, right? But we have 6 right here. And for all of these, each of these ranks, countries, capitals should all be unique. That makes perfect sense. As well as these, these populations are such specific numbers and such large numbers. I would be shocked if any of these were similar. And then for these world population percentages, it's much lower. And again, that makes a lot of sense, because when we're looking at, and we'll pull it up right here, when we're looking at these world population percentages, a lot of them are really low, 0.00, 0.01, like this one, 0.2. There are a lot of really low values for those small countries. And so those are all, one unique value. Now, let's say we just have this data right here and we want to take a look at some of the largest countries. And we can easily do that. We could say max and take a look at the largest country, but I want to be a little bit more strategic. I want to be able to look at some of the top range of countries. And we can do that based off this 2022 population. So we'll say df.sort_values. This is how we sort and not filter, but order our data. So we'll do sort values, and then we'll do by is equal, and then we'll specify that we want this 2022 population. And then we're going to say comma, and we'll say, actually, let's just run this as is, but we'll do head, because we just want to look at the top values. So now we're just looking at the very top values. So what we're looking at is actually these 2022 population. That's what we're filtering on or sorting on, basically. And we're looking at the very bottom values because it's sorting ascending, so from lowest to highest. So this Vatican City in Europe is 510. That's the value that we were looking at earlier. Now we can do comma ascending equal to false, because it was by default true. We can do false, We can do false, and then it'll give us the very largest ones. So if we just take a look at the top 5 largest by population, we're looking at China, India, United States, Indonesia, and Pakistan. And we can even specify that we want the top 10 in this head. We can bring in the top 10, and we also have Nigeria, Brazil, Bangladesh, Russia, and Mexico. And you can do this for literally any of these columns, whether you want to look at continent, capital, country. You can sort on these and look at them, and you can even look at things like growth rate, world percentage. This one seems really interesting. Let's just look at this one really quickly before we move on to the next thing. If we look at this world percentage, just China alone, I believe, just China alone is 17.88% of the world. So 17.88 and 17.77 and that's China and India. And those are very large countries with a high population. That makes a lot of sense why that is the highest world population percentage. Again, just getting in here, looking around. That's all we're really doing. Now I want to look at something, and I have always liked doing this, which is looking at correlations. So correlation between usually only numeric values. We can do that by saying df.corr and in parentheses, and we'll run this. And what this is it is comparing every column to every other column and looking at how closely correlated they are. So this 2022 population, if we look across the board, it's very highly, I mean, this is a 1-to-1. This is highly correlated to each other. And that almost for all of these populations, they're very closely tied to each other, which makes perfect sense because for most countries, they're going to be steadily increasing. And so they're probably almost exactly correlated. But we can look at these populations, and if you look at the area, it's only somewhat correlated. And that's because in some countries, you know, they have a very high population, but a small area, or vice versa, a small area and a very high population. So there isn't a 1-to-1 correlation there. But it's hard to really just glance at this and understand everything that's there. We could just visualize it and it would be a lot easier. So let's go ahead and do that. Let's go down here. We're just going to visualize this using a heat map, basically. So we're going to say sns.heatmap and an open parentheses. And the data that we're going to be looking at is df.core correlation. And then we also want to say anote equals true. I'll kind of show you what that looks like in just a little bit. But let's do plt.show. And this will be our first look. And I need to say show, not shot. We can get a little glimpse of what it looks like, but this looks absolutely terrible. Let's change the figure size really quickly. So I want to make this much larger than it already is. We'll do plt.rc params, oops, right there. Do an open parentheses. And then right here, we're going to do in quotes, do figure.fig size. This actually needs to be in brackets, I believe. Just like this, not parentheses. We'll say fig size is equal to, and now we can specify the value that we want. Let's do 10,7 and see if this looks any better. No, that doesn't look good. Do 20. Okay, that looks a lot better. And, you know, this is just a quick way because it gives you basically a color-coded system. Highly correlated is this tan, all the way down to basically no correlation or negative correlation even, which is black. So when we're looking at these 2022 populations, and these are our populations right down here on this axis, we can see that all of these are extremely highly correlated very quickly. Whereas the rank really has nothing to do. It's negatively correlated. It doesn't really have anything to do with it. Then for the population and the world population percentage, it again is quite correlated except for the area, density, and growth rate. So I find that really interesting that, you know, the density, the growth rate, and the area aren't really all that associated or correlated with the population numbers. That is, I kind of would have assumed that on some level they went hand in hand. The area does, which, you know, again, makes sense, you know, larger area, larger population, that kind of thing. But even density, I guess density and growth rate I can see because that's a percentile thing. That could be definitely not correlated. But I thought the density would be more correlated than it is. All that to say is this is one way that you can kind of look at your data, see how correlated it is to one another. That can definitely help you know what to analyze and look at later when you're actually doing your data analysis. Let's go right down here. Something that I do almost all the time when I'm doing any type of exploratory data analysis like this, I'm going to group together columns, start looking at the data a little bit closer. So let's go ahead and group on the continent. So let's look at it right here. Let's group on this continent because sometimes when you're doing this EDA, you already know kind of what the end goal of this data set is. You know kind of what you're looking for, what you're going to visualize at the end, that really comes in handy when doing this. But sometimes you don't. Sometimes you're just going in blind. And so far, we've really just been going in blind. We're just throwing things at the wind, kind of seeing some overviews, looking at correlation. That's all we've done. Now I kind of want to get more specific. I want to have like a use case, something that I'm kind of looking for, not doing full data analysis, or not diving into the depths, but something we can kind of aim for. So the use case or the question for us is, are there certain continents that have grown faster than others, and in which ways? So we want to focus on these continents. We know that that's the most important column for this use case, this very fake use case. So we can group on this continent and we can look at these populations right here because we can't really see growth. You can see a growth rate, but the density per kilometer, we don't have multiple values for that. It's just a static one single value. Same for growth rate, same for world population percentage, but we have this over a long span, many, many years, 50 years of data here. So this, we can see which countries have really done well or which continents have really done well. So without, talking about it even more, let's do df group by, and then we'll say continent. Oops. Let me just copy this. I'm not good at spelling. We're going to say df group by, and then we'll do dot mean. And we can just do it just like this. And now we have Africa, Asia, Europe, North America, Oceania, and South America. Okay, so if I'm being completely honest, I knew most of these. All right, I'm no geography expert, but I knew most of these. I don't know what this Oceania is. I genuinely don't know what that is. So let's just search for that value and see. We'll come back up here in just a second, but I want to kind of understand what this is. So we're going to df, and we'll say continent. Let me sound that out for you guys. Then we'll do dot string dot contains. Oops, contains. Good night. And then I want to look for Oceania. And let's run this. Oh, I need to do it like this. Now let's run this. So now we're looking at our data frame and we're seeing when the values have this continent as Oceania. Okay, so these look like islands, I'm guessing. So we have Fiji, Guam, New Zealand, Papua New Guinea. Yeah, these look like all, I'm guessing based off the continent Oceania. Oceania. Guys, this is tough for me. Okay, I'm doing my best. This is part of the EDA process. I don't know what that means. I don't know what Oceania. Jeez, I'm just gonna call it Oceania. That's so wrong, but it's so easy for me to say. I now am seeing this and it looks like islands, which would make sense because for their average, they have the highest average rank. And I'm guessing that's because they're just mostly small continents. So let's order this really quickly. We're gonna do dot sort underscore values, do an open parentheses, and I want to sort on the population. We're just doing the average population. We'll do by equal. So on the average population, and we'll do ascending equals false. So when we're looking at this average or the mean population, Asia has the highest population on average. Then we have South America, Africa, Europe, North America, and then Oceania at the very bottom, which makes perfect sense. Again, small islands. World population percentage. So each of those countries in Asia makes up about 1% on average. Really interesting to know and just kind of look at this. And the density in Asia is far higher than almost double every single other continent. Really, really interesting, actually, now that I'm looking at this. But, that's something that I would actually look into. And I would be like, what is this Oceania or Oceania? What does that mean? And, let me look into that. Let me explore that more because I want to know this data set. I'm trying to really understand this data set well. But what I want to do now is I want to visualize this because I just feel like looking at it, it's hard to visualize. And again, the use case that we're saying is which continent has grown the fastest. Like it could be percentage wise, it could be, as just a whole on average. Let's take a look. So we're going to take this and let's copy it like this. Let's bring this right down here. So let's look at this. So if I try to visualize this, and let's do that. Let's do df2 is equal to, because I already know it's not going to look good just based off how the data is sitting. We can do df2. Oops, what am I doing? I don't need to do that, but I will. Okay, df2, and we'll do df2 dot lot, and we'll run it just like this. As you can see, Asia, South America, Africa, Europe, North America, Oceania. We can kind of understand what's happening, but these are the actual values that are being visualized, not the continents, which is what I wanted. In order to switch it, and it's actually pretty easy, and this is something that is good to know. We can actually transpose it to where these continents become the columns and the columns become the index. And all you have to do is say df2 dot transpose, and we'll do this parenthesis right here. And let's just look at it, and then we'll save it. So now all of these columns are right here, and all of the indexes are the columns. So let's say df3 is equal to, and I'm just doing that so I don't, write over the df or my earlier data frames. So now we have this data frame 3. So now let's do data frame 3.plot, and it should look quite a bit different. Whoops, I didn't run this. Let's run this and run this. And as you can see, this does not look right at all. And the reason is because we're not only looking at the correct columns. We have this density in here, word population percentage, rank. We don't need any of those. The only ones that we want to keep are these ones right here, this population. Now we can do that, and we can just go right up here. This is where we created that data frame 2 that we transposed. We can go right up here, and we can specify within this, we actually only want specific values. Now we can go through and handwrite all of these, and by all means, go for it. But I am going to go down here. I'm going to say df.columns, and I'm going to run this. It's going to give us this list of all of our columns, and I'm just going to, you can just copy this, and you can put it right in here. I think I need a list with it. I think it needs to be like this. If I'm, let me try running this. Okay, so this worked properly. You can do it just like this, or a little shortcut if you want to do it like that. If you want to do a shortcut like, I would hope you would just do df.columns, just like how we looked at down here, except since this is an index, we can search through it. So we can just say 0, 1, 2, 3, 4. Okay, so we can do 5 up to 13, because I think it's 7. And we'll just, let's see if this works. It may not. I may actually need to go like this. Let's see. There we go. So you can just use, the indexing to save you some visual space, gives you the exact same output. So now we have this. This is our df2. Now let's go down and transpose it. So now we just have these populations, and we have our continents right here. And then now we're going to plot it. And this looks good, although it's backward. Okay, it's backward. So what I actually want to do is not this. That is a quick way to do it, although not the best way to do it. So I'm actually going to copy all of these, and although I said it would save us time, it did not at all. So I'm going to put a bracket right here. I'm going to paste this in here, and I'm literally going to change these up. I might speed this up, or I might just have you sit through this because, this is an interesting part of the process, and I want, you to get the full experience. You know what? Now that I'm talking about it, that is what we're going to do. You guys can hang out with me. This is a good time. We have 2010, 2015, 2020, and 2022. Now let's run it. What did I do? Oh, too many brackets. There we go. So now it's ordered appropriately. We have 1970 all the way up to 2022. This is how we want it. Let's transpose it appropriately. Let's run it. And now we basically have the inverted image of this. Now just at a glance, and we haven't done anything to this except for literally what we are looking at. At a glance, we can see that from 1970, China, Asia and China are already in the lead by quite a bit. And it continues to drastically go up, especially in the 2000s. Like right here, it explodes, like just straight up. Then kind of starts going up and just leveling off. Every other continent, especially Oceania, is just really low. It never has done a bunch. Let's see, look at green. Green has gone up from, let's say 0.1 up to about 0.2. So they've almost doubled in the last 50 years. And again, you can just get an overview, a high level overview of each of these, continents over the span of this time. So this is kind of one way that we can, look at that use case. We're not going to harp on that too long. I just wanted to give you an example. Like, when you're looking at this, sometimes you'll have something in mind of what you're looking for and you go exploring and just kind of find what's out there and find what you see. The next thing I want to look at is a box plot. Now, I personally, I love box plots. They're really good for finding outliers. And there's a lot of outliers. I already know this because the average, the 25th, 50th percentile are very low. And then there's some really just big outliers. But for your data set, it may not be that way. And those outliers may be something that you really need to look into. And box plots have been something that I've used a lot where I found those outliers that way and started to dig into the data to find those outliers and, came across some stuff that I'm like, oh, I have to clean this up. I have to go back to the source. Really, really powerful and useful to be able to find these. So all you have to do is df.boxplot. Yeah, let's take a look at it. And this already looks good as is. Maybe I'll make it a little bit wider. Let's do fig size. Oops. Sorry. Fig size is equal to, let's try 20 by 10. Okay, that didn't help at all. I apologize, thought it would, but let's keep going. What this is showing us is that these little boxes down here, which are actually usually much larger because you have a more equal distribution of numbers or values. In the small value, this is where our averages lie. This number right here is the upper range. And then all these values, all these open circles, those actually stand for outliers. So we're looking at the 2022 population. There's a lot of outliers. Now, for our data set, knowing our data set is really important. Outliers are to be expected, especially when most countries or continents are small. So we're looking at, all of these little dots are outlier countries or outlier values, which each value corresponds to a country. So if this was a different data set, I would be, searching on these and trying to find these so that I can see what's wrong with them, if anything, or if they are real numbers. Like if this was revenue, everyone's revenue is way down here, and then there's one company that's making like $10 trillion, that'd be an outlier up here. And it would definitely be something that you want to look into. For our data set, knowing that, we're looking at population, this is more than acceptable and oddly enough. But that's what box plots are really good for, showing you some of those quartiles, the upper and the lower, as well as denoting these points that fall outside of those normal ranges for you to look into. So really, really useful. So now let's go down here, pull up our data frame again, and we've kind of just zoomed into the whole EDA process. There was one last thing that I wanted to show you. And this is the very last thing that we're going to look at. We're ending on really a low point, if I'm being honest, because the last kind of stuff was much more exciting. But there is something df.dtypes. Oops, let's do df.dtypes. And we'll run this. Now, just like info, it gave us these values, but we're actually able to search on these values now. So these object, float, and integer, we can search on those, which is really great because we can do include equal, and we can do something like number. And none of these are numbers, right? Or none of them explicitly say number. But when we run it, I'm getting an error series object not, oh, that's because I'm doing dtypes is for a series. We need to do select underscore dtypes. Now let's run this. Now it's only returning the columns in this data frame where the data types are included in this number. So you won't see any, country or any of those text or the strings. If we wanted to do that, we go in here and say object and run that. And this is another really quick way where we can just filter those columns to look for specific, whether it's numeric, we could even do float in here And so now it's not including that rank, which was an integer. So we can specify the type of data type and it'll filter all of the columns based off of that, which, when you're doing stuff like this, it is good to know what kind of data types you're working with and look at just those types of data types, because there might be some type of analysis you want to perform on just that, whether it's numeric or just the string or integer columns within your data set. So again, ending on a low note, I apologize. Everything else that we looked at, all those other things that we looked at are all things that I typically do in some way or another when I'm looking at a data set. Exploratory data analysis is really just the first look. You're looking at it, you're going to be cleaning it up, doing the data cleaning process, and then you're going to be doing your actual data analysis, actually finding those trends and patterns and then visualizing it in some way to find some kind of meaning or insight or value from that data. And again, there's 1,000 different ways you can go about this. It does typically depend on the data set, but these are a lot of the ways that you'll clean a lot of different data sets. And so, that's why I went into the things